discussion over here. So here, when if I have to talk about the machine learning or artificial neural network or multi-layered neural network, right? So they required what? Multi-layered neural network. They required a structured data, right? A structured data is what? It's like having a fixed number of rows and columns, isn't it? Okay. Machine learning or multi-layered neural network requires this kind of data, right? Like, Excel data, tabular data, kind of thing, right? When you have unstructured data, okay, unstructured data is what? Like text. Text is unstructured data, right? Why it is unstructured? Because every time the sentence length is not going to be same, right? Like say in this sentence, how many words do we have? 1, 2, 3, 4, 5, 6, 7. It is different, right? Next sentence I have different number of words. Okay. Next sentence I have different number of words. Correct. So if you convert it into a tabular form, okay. Suppose you have 5 sentences. Sentence 1, 2, 3, 4, 5. If you convert this thing into a tabular form, okay, and thereafter you are doing what? In each cell you are putting one word, okay, from each sentence, right? So it will not create a structure. Like here, let's say I like movies, okay. Here I am going to office, right? So now these will remain blank, right? So that's why texts are called what? Unstructured data. Okay. Then images are also called unstructured because if you collect suppose 20-30 images, all images will not be of same intensity, right? That means the pixels, the resolutions of all the images will be different, right? So when we work on any kind of predictive model, we either work on structured or unstructured data. Okay. There is semi-structured also, that is a combination of structured and unstructured kind of thing. Now here, if we are working on suppose text data like this, okay, and we are working over to predict the next word in the sequence, okay, so that means we are working on something called sequential data, right? What are we doing right now? Our whole discussion, okay, is based on the sequential data because it is in a particular sequence, right? So what are you doing? We are working on sequential data. Okay. Now, why this is important to know? Okay. If we are working on text data, we are working on sequential data, right? So when people started first with the sequential data, right, they started using RNN, that is recurrent neural network. Okay. This was the first thing that we explored, right? Like you can see, this whole time frame, if you put like this, around 2013 this whole thing started. Okay, so at that point of time, in the year 2013 or 12 or 13, around that, the first thing that was trying to figure out those concepts are called tokenization, okay, or you can say word embedding. Okay, now what is tokenization or word embedding? Like people thought like, okay, can we let the system understand our natural language? Like suppose if I'm speaking something, is it possible that system can understand it, can figure out some information from it, okay, can identify the sentiment out of it? If whatever I'm speaking in my natural language, if I want my system or computer to understand it and give some sort of sentiment analysis or just try to find out some meaning of it, then what can be the process, right? So it is thought like okay, so we can start with tokenization. Okay, people thought like, now what is tokenization? It's like, let's say right over here, I like playing cricket. Okay, so in this thing, each word is what is one token. Okay, so that is called the concept of tokenization. Okay, that means instead of just putting everything to the system, just do one thing, just separate word by word. Okay, just identify all the words from that. Okay, separate it like this, right? So that is called tokenization. Thereafter, the concept of word embedding. Word embedding is like converting these things into numbers. Okay, converting these things into numbers. Right. So there are multiple ways of converting into number that I will discuss. Right. Thereafter, we have around 2014. These things people started using in a neural network that is called RNN or LSTM. Okay, these neural network came into picture because they were working quite good on the sequential data. Right, here we don't use CNN because CNN is used for non-sequential kind of data. Multi-layer neural network is used for structured data. RNN used for sequential data. How? We'll discuss. Right, so this was working good, RNN, thereafter LSTM, but they are having some limitation. This is good for only some limited length of data. When the data length increased a lot, they start forgetting the things. Right. Thereafter, 2015. Okay. Here there is a concept given that is called attention mechanism. Okay. And this actually changed the whole game. Right. And the paper that actually created the revolution in this particular field is Attention All You Need. Okay, this is a research paper which changes the whole game of AI. Right, like there was a research paper published and that research paper gives the birth to Bitcoin. Okay, around 2000 or something, someone published a research paper and Bitcoin came into picture, and then cryptocurrency, and you can see the changes. Okay, in the world of virtual currency. Now, this is a research paper which actually changed the game of complete AI. The kind of development that we right now, the kind of development that we can see at this stage, this kind of development were expected. Means almost it was expected that it would take almost 30 years, 25 or 30 years. Okay, like in the year 2015 or 16, people were knowing that we will have the AI and that AI is going to do a lot of things. But it was expected that it will be done by year 2040 or 45. But this research paper came, and then this thing came, transformer, and this changed the whole game. And the kind of development that were expected in next 30 to 40 years, that development happened in just 4 to 5 years. Right, so around 2015, some concept that came that was called attention mechanism. So what is attention mechanism? It works like this. Suppose if I give you any article to study, okay, suppose if I give you this particular paragraph to study, okay, that I ask you to just to read this paragraph, right? So how our brain functions? Our brain will just read it, but it's not like that each word it will give the equal attention, right? Our brain actually identify that which information is more important over here, which is just kind of not so important, and whichever is more important, okay, our brain will automatically give more attention to that particular kind of a part of that whole text. Okay, and only those important part which had been given attention, higher attention, will remain in our mind. Rest everything will not keep in our mind, isn't it? Anything like whenever you read any large document, any a book, right, we just pay attention to those things, those facts which are very important. That's how our brain functions. Okay, so this article, this particular research paper about that only, that can we create some system. Okay, this was about creating a system which can automatically identify that where to pay attention, what are the important part, and just keep only those things into the context. Okay, those things which are not so important, don't put those things into the context. Okay, for example, if I write over here, let's say it was a nice test we experience at the restaurant we visited last Sunday. on last Sunday, and the name of restaurant was ABC restaurant. Okay. Now, if I ask you something over here, that if suppose this information is being given to you, and it will be asked that tell me what was the any analyst is there, and the analyst wants you to identify the feel, like what customer feels, okay, or what was the customer experience, or what was the sentiment of the customer. So what you do, your mind or your brain will automatically focus more on what, on this part. Okay, this is a part which will be given a very highest attention, because out of this whole text, only this part is representing that the person is having a very good experience, right? So this particular transformer was built keeping in same mind. That means whenever something is asked, it is not necessary that go through everything, okay? Because if you're going through everything, there is a high chance that we may miss a lot of things, okay? So it is like, instead of going through each and every part, just try to find out those parts which needs to be given higher attention for that particular context, and based on that respond, right? So that was a mechanism, that kind of mechanism was kind of proposed, and it is called attention mechanism, right? Later on it's like multi-head attention, or different kinds of attention mechanism like single attention will develop, that we'll discuss. So based on this attention mechanism, in 2017, first time someone came with a concept of transformer. Okay, first it took 2 years from here to here. Okay, 2 years it was just a research paper, somewhere it was just existing. Okay, thereafter in 2018 something, okay, BERT came. Okay, BERT is like bi-directional. Okay, bi-directional encoder, receiver, transformer. So this is also a BERT is also a kind of a transformer, bi-directional encoder representation from transformer. Okay, so what it does, the generic transformer, or the transformer that was initially proposed, will read your data from the beginning. It means what? The transformer, it's like read the information like this. Okay, like this, right? Or BERT do what? It's bi-directional, from this direction as well as from this direction. Okay, so Google created BERT, and transformer was, I guess it was built from the OpenAI initially, right? And then we have over here so many things were developed, and now we are running in 2025, in which so many other developments were happened in this particular field like BERT, and thereafter, foundation model came around 2020. Okay, the model that came was foundation model and all. So these things will explore one by one. Okay, but first, to understand all these things, what we need to understand, this part first, like how a system considers the word. Okay, if we can understand how a system considers the word, rest all journey will be very easy, right? So system considers the word, it can only consider the word in a numeric form, correct? System will only consider the word in its numeric form, right? Now how it will consider the words in a numeric form, right? So there was a step-by-step development happen in this field. Okay, like suppose if I have a document, that means I have kind of a document in which I have two sentences. Okay, let's say the sentences are, I am a cricket, let's say I am a good cricket player. Okay, this is one text. Next text is what? Raju is is not okay, let's say Raju is a bad chess player. Okay, like this, right? So suppose I have to build a system which can identify the sentiment of a sentence, right? So what I did, I just collected so many sentences. Some of the sentences are having the positive sentiment and some of the sentences are having the negative sentiment. Okay, so this thing will be given a label 1, this thing is given a label 0, right? That means all the positive sentiments, all the sentences representing positive sentiments labeled as 1, and all the sentences representing negative sentiments, they are labeled as 0. First thing is, to use it for the machine learning, I have to convert this thing into numerical form. So how can you convert into numerical form? To convert this thing into numerical form from this whole data, I need to find out all the unique words. I am a good cricket player. Okay. Then after Raju is, I will not use because A is already used here, right? So A can't be used. All unique words I'm trying to find, right? Raju is a bad chess. Okay, I'll not use player because player is already there. Okay, and thereafter here we have label, right? And thereafter this thing, right? Now we have two sentences, right? So document. So for each document, okay, it can be generated like this. Like this will get a value. Like for the first document, this is 1, 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 this is 1. For the second document, this is 1, this is 1, this is 1, this is 1, this is 1. Right. Now rest all are 0.
Sir. Sir, I just want to know one thing only. How to visualize a document. Actually, we usually when study embedding and all something. So to visualize the document is a little tough actually.
Document. No, I'll explain, right? We'll go step by step. I'll show you how document can be visualized, how embedding can be done, everything. Okay. Just step by step. All right. Okay. So this was the first generation encoding. Okay. First generation. That means it just at the start. Like I'm talking about in the year 2012 or 13. Okay. In the first generation embedding, people thought like if I have a large document or so many words are there, and based on that words, here we are not talking about word generation. Here we are not talking about word generation. Here we are talking about like just to create a system through which machine can understand words. Here we are just trying to create a system through which machine can understand words and can do the categorical prediction, like spam, like identifying my spam mail or ham mail. Okay, like identifying a positive sentiment or negative sentiment. So this was proposed initially. Okay, but in this case, you know, this was having some limitation. What was the limitation this guy is having? Okay, the limitation is this is actually not identifying the structure within the words. It is just considering each word independently. Okay, it was just considering the each words independently. Words are just treated individually. Okay, words are treated individually, and if you have a very large text data, right? Suppose you are working with a text data in which you have suppose kind of thousands of reviews are there. Okay, you have thousands of reviews are there, or suppose 10,000 reviews are there. So because of 10,000 reviews, suppose you have a kind of a 5,000 unique words are there, or let's say 2,000. Let's say 2,000 unique words, or let it be more lesser. Why 2,000? Let it be, in 10,000 reviews. Let's say you have 1,000 unique words. Okay, 1000 unique words. That means when you convert this 10,000 reviews, 1000 unique words into this kind of data structure, that means what will be your data size? 10,000 rows will be there, because as many document, as many sentences, that many data row. Okay, 1000 unique numbers, that means 1000 features. So it's like, feature size were getting increased a lot, right? So it is just increasing the feature size, and because of increased feature size, the size of model is increasing, right? And at the end, it is not identifying the pattern or the relationship between different words, like how good and cricket, or how cricket and player is related to each other, not identifying. Okay, how chess and player is related to it, because these two words are highly related to each other, right? It is not identifying. How I and M is related to each other. I and M is highly related, right?
How it was predicting?
How it is predicting? Yeah, how it will be able to predict? It will be able to predict with the help of ML model. In the ML model, what we do here, these things will be considered as the features. Okay, these are the features. Okay, and this is your label, right? That is Y. Okay, and thereafter we can use different algorithms that are used in machine learning, like logistic regression, support vector machine, or decision tree classifier, or random forest classifier, okay, or bagging or boosting. Multiple machine learning algorithms are there. Those algorithms will find out the relation between these features and labels. Okay, those algorithms will try to find out the best relation between features and labels, and after finding out the best relation between features and labels, will give you some trained parameters called coefficients, and using those coefficients, prediction can be made. All right, but to understand all those things, again, you need to have some concept of machine learning. If you don't know the machine learning part, then at a high level, just don't go that deep into it. Okay, just at a high level, you should know that in machine learning, there used to be features and labels, and there are some algorithms exist. Those algorithms find out the relation between features and labels to give you a model which can make the predictions later on.
Here, label basically sentiment.
Right. Here, labels are that we have already defined. 1 we have defined for positive sentiment, and 0 we have defined for negative sentiment. This line is representing features of second sentence, and this line is representing features of first sentence. All right. Okay, so if you don't know machine learning, please don't worry about it. It is just at a high level, you should know that it will just use these features and labels to build a system which can make some predictions.
Sir,
but here
actually मेरा वही सेम डाउट है सर, लाइक ये जो आपने 10K बोला और 1K बोला, so मतलब एक्चुअली मैं अपने से भी पढ़ने की कोशिश किया था, थोड़ा यहाँ पे कंफ्यूज हो गया था.
बताइए, प्लीज टेल मी.
Let's suppose you have said like there is 1000 unique word, right? So we might be having for 1000 unique word, we be having 1000 features.
Correct.
We will be calling it as a column. Right?
Correct.
अब ये D1, D2, D3 ये reference क्या है सर, वो थोड़ा समझ नहीं.
D1, D2, D. Okay, fine. See, here D1 is representing your first sentence. What I said, you have to convert your text into numeric form, right? So in the first sentence, we have I is there, so this value is 1. M is there, right? This is D1, this is D2. Okay. So here 1, M is there, A is there, good is there, cricket is there, play is there. So these words are there in your first sentence, right? So they are 1. Okay. In the second sentence, we have Raju. So Raju is 1, is 1, A is 1, bad is 1, chess is 1.
Okay.
Okay. Rest all are 0.
D1, D2 is basically the sentence.
Yeah, sentences that is being converted into numeric form.
Number of sentence that has been converted.
Correct. So that means if you have 100 sentences, right, then what happened? You will have 100 data rows, right?
Okay.
Right? And in those, if you have 10,000 sentences, then you have 10,000 data rows.
सर तो हम जब भी कभी भी डील करेंगे तो हम उसमें सेंटेंस या सीक्वेंस को डिफाइन कर देते हैं, राइट, कि कितने नंबर ऑफ डॉक्यूमेंट हैं.
Correct. Right, but this model or this kind of operation was having a challenge that it was just considering each word individually, right? It is not finding.
इस मॉडल को क्या बोलते थे?
Sorry,
इसका नाम क्या था मॉडल को? What it is called, this model?
This was actually this is not. Just a minute.
कुछ रहा होगा. अच्छा,
I'll tell. Just a minute.
और
see, this, can you hear me now?
हाँ.
See, model will be created later on. Like here, it is just about converting the data into like your text data which was unstructured into the structured form. This is creating the data. Okay, model will be created after this. That means after this, we can use any machine learning algorithm to create the model. Like I said, SVM, logistic regression, or this is we can use to create the model.
इसमें डेटा आता है, जैसे क्वेश्चन था कि अगर इसमें तो बहुत सारा मतलब सेंटेंस चाहिए होगा, बहुत सारा वो चाहिए होगा यूजर इनपुट, बिकॉज जैसे कोई नया यूजर आता है और वो कोई अपनी जैसे शशि थरूर टाइप इंग्लिश कोई लिख रहा है, वो वर्ड ही नहीं है इसमें इनके पास.
अभी करते हैं डिस्कशन. I'll come to that, right? That concept that is called out of vocabulary concept, right? So abhi, like let me finish, right?
Sure. Sorry.
Sir, may I ask you one question?
Please tell me.
Sir, this matrix is TF-IDF matrix.
No, this is not TF-ID. Let me finish. I'll explain TF-ID, right? Okay. Wait, have patience. So it is all about, we have the sentences. Those sentences are considering the words. Machine can't process words. Machine needs numeric value to process, right? And these words, each sentence can be of different length. Okay, some sentences may be containing 5 words, some sentence may be containing 4 words, some sentence may be containing 10 words. Now, we have to convert these things into the structured data so that it can be used for machine learning model building, right? So this process is called, you can say, feature engineering kind of thing, like just converting each word into the numerical form, right? It's like we have a text data that is feature and converting it into the structure data, right? So this you can consider as word feature engineering. Okay. All right. But the problem over here is each word is considered over here separately, right? This is something that each word is considered uniquely. So your model, whatever the model you can use over here, like whichever algorithm you use, that algorithm will not find out the relation between the words, like how I and M is related can't be figured out, how A and good is related can't be figured out, right? So what are the solutions? Okay.
So basically text data is sequential. Here this way we are converting sequential into structured.
Correct.
And we are calling it as feature engineering.
Yeah, we call it a feature engineering. Like feature engineering is just about kind of a work on the features or the features given to you there, or creating in the feature engineering, lot of things are there. Here we are just converting the things into a structured form. Okay. All right. So now the point is over here. If I have a sentence, okay, and this sentence, any sentence like I am a cricket player, okay, or Raju play, let's say chess, okay, like this. Okay, now here is like, to convert this thing into numerical form, I have to find out all the unique words, and then based on the unique words, we can convert into numerical form. Okay, but challenge is what? Each word will be considered uniquely. So thereafter the concept of n-gram came. Okay, the concept of n-grams. Okay, now what is the concept of n-grams? Okay, to understand this, let's say 1 gram. What is 1 gram? 1 gram is like, consider each word uniquely. I am a cricket player. Okay, Rajiv play chess. Okay, just consider each word uniquely and then give them the, just consider like this each word uniquely. And if you consider each word uniquely, then what happens? You can convert this thing into numeric form like we did earlier. Isn't it? Like this? Isn't it? This is document 1, document 2. For document 1, this one will be 1. Okay, for document 2, this will be 1. Rest all will be 0. So this is like our features. Okay, and thereafter the label whatever we want. So, but this is not identifying the word relationship. So it is said that let's use 2 gram. Okay, that means here the 1 gram tokenization. Let's use 2 gram tokenization. Okay, in 2 gram tokenization, what happened? We started using 2 words together, like I am. Okay, thereafter MA. Why it was used? It was used to find out the solution so that because the problem was there. Now everyone is proposing different kinds of solution, right? So this thing came into picture, in which it is said that we can pick 2 words at a time. Okay, cricket player. Okay, and thereafter Rajiv play. Okay, thereafter play cricket. Okay, like this. Now if it will be converted into the numeric form, then it will be like this. Okay, this is for document 1, document 2. So for the first guess, I and M is there together, and M and A is there, A in cricket is there, cricket and player is there, right? Here we have in the second, this one is there, isn't it? So this kind of thing happened, right? Like just picking up 2 words. So now it's like, now shall I, if it is a small document, then it's good, right? It can find out the relation between any 2 words. Okay, with this, obviously a model can be there which can work on the combination of 2 words we are using to represent it together. So some relation can be figured out. Now 3 gram will use 3 words.
Sir, sorry sir, out of curiosity, just say I और M है, so for the इस combination के लिए एक numerical representation होगा, right? अब अगर मैं जैसे IMA अगर मैं 3 ग्राम कर देता हूँ, तो इन तीनों के कॉम्बिनेशन के लिए एक न्यूमेरिकल रिप्रेजेंटेशन होगा.
Correct. IMA. Thereafter the second one is MA cricket. Okay. Thereafter we have A cricket player.
Okay. And it's just to capture the relation, right?
Right.
And because number of features तो constant रहेंगे, चाहे वो 1 gram हो, 2 gram हो, 3 gram.
Correct. Right. But here the challenge was how to decide. Okay. We have to use 1 gram, 2 gram, 3 gram, because sometimes 4 words combine together and create some sequence. Okay, and the relation between those words, the structure of those words are important. Correct. And this combination is also somewhat difficult. It's not that easy that you can combine and deciding what combination will be good. Yeah, if you have a small size data, then it's fine. Okay, it is good if you're working on a single PDF. Okay, some 1,000 words are there, right? But if you're working on very large scale data, it is not that easy, isn't it? So this was just something that was good. I'm talking about like what kind of development happened throughout the year in this field. Okay, so that at the end we'll reach what is currently we are using. All right. So this was happened. Thereafter, as you said, 1 meter. Okay, so these are the different encoding technique that were there. Okay, 1 gram encoding, 2 gram encoding, 3 gram encoding. Okay, so these things were going through the years. Okay, now I don't think that anyone is using it, but yeah, we should know about it. Thereafter, something that came into picture that you say TF-IDF. Okay, TF-IDF, the full form is term frequency. Okay, inverse document frequency. Inverse document frequency. All right. Okay, so term frequency is like, it just represents how often a word appears in a document. Okay, this is how often a word appears in a document. That is your TF. And inverse document frequency is what? How rare. Okay, it is like how rare. This is a calculation of how rare that word is across all document. All documents. Okay, so when talking about document, that means sentence, right? That means first we'll calculate how often. So the formula over is TF multiplied by IDF. This is the formula, okay, for the TF-IDF.
Sir, TF is for only one document.
Right.
And IDF for all document.
Correct. Okay, let's take an example to understand it, right? This is also a way of encoding the things, right? So let's say I have a document 1 over here. Okay, in which it is like AI.
Sir, document means sentence.
Right. AI is the future. Okay, this is one document. Thereafter I have document 2. AI and ML are the future. Okay, thereafter we have document 3. This is what? I love AI and data. Okay, right. Now it just helps in what? In finding out the important words in a document that are very unique or that are very relevant. Okay, that means in this whole 3 document, AI is something which, how can you say that AI is very relevant? Because AI is appearing again and again, right? Okay, so TF-IDF is a encoding technique, okay, that actually finds out important words in the document that are very unique or they are relevant. It is not just common word. Okay, like suppose you have a library of books, right? And you want to find which words are most important in a particular book. Okay, because there are some words like this, is, or, and. Okay, the words like, this, is, and, or, they appears everywhere, right? But we can't consider them as important words. Because to find out the information, to find out some information of particular, like suppose sentiments, or to find out like this information belongs to which context, these words are not important. To identify the context, these words are not important, but these words are appearing everywhere, right? So TF-IDF do what? It just highlights unique terms that defines each document, right? So here, if I have to calculate the TF, let's try to calculate the TF over here. So what is your TF?
TF is for D1 it is 1.
I'll calculate. Let me just Just allow me for time. So here, let's calculate the TF. Calculate TF for AI. Okay, IDF will be calculated for each word. Okay, so TF for AI will be what? Document 1 has AI, right? Document 1 has AI over here. Okay, AI is the future, but it is having 4 words. How many words? It is having 4 words, right? So AI appears one time out of 4 words. So what it would be? 1 upon 4?
0.25.
0.25 for document 1, isn't it? Now let's calculate the IDF. Okay, so IDF is what? IDF is like AI appears in all the 3 documents, right? So IDF is equals to log of total document upon docs with the word. Okay, that means log of total document is 3 and all 3 document is having AI, so it will become 3 upon 3. So this is become log 1. Okay, log 1, which will be equals to 0, right? So now TF IDF, if you will calculate TF multiplied by IDF, it will come out to be 0.25 multiplied by 0. This is equal to 0. Okay, if it is 0, that means it is very common. Okay, as it is common, it will get no importance. Okay, this is very common word, and as it is common word, it will get no importance. All right. Now, if you
sorry, one question I have is IF you already calculated for D1. Don't have to calculate D2 and D3. IF. TF, right?
Sorry,
TF.
TF and IDF. Yeah, it will be calculated for D2 and D3 as well. Okay.
And then,
so for D2 and D3 also you can it will be calculated. For D2 it will be what? It would be like 1, 2, 3, 4, 5, 6, right? So it will be what? 1 upon 6. 6 words are there. So for AI it is 1 upon 6, but still for D2 also it will be 0, right?
Yeah,
because IDF is
0. So how we go final? Is it any final number we get? That's why.
See here, when it is, these things will be converted into the numerical form. So for converting into numerical form, AI will get the value 0, right? Okay, so AI will get the value 0 for all of them, right?
Yes.
Isn't it?
Oh, okay. It is like this. Okay, got it. No, I just wanted to know if it is not 0 in case, how we gonna represent it.
I'll tell. Okay, I'll tell. Let me just try to do this thing. So here, actually here, AI is the future. Rest we have some values. For this guy we have 0, then 1, 2, 3, 4, 5, and here I have what? I love AI. So here it is 0 and data. Right, fine. So these guys will have different number. Now let's talk about future. Right. So for the future, you will again calculate. Okay. So for the future, TF for future. What is the TF for future? TF for future will be
again 0.25.
Yeah, 0.25. Okay. No, not 0.25. Yeah, 0.25. That's fine. And IDF for future will be what? IDF for future will be it would be log of
2. Log of 3 by 2. 1.3
by 2. That would be equals to close to, you can just calculate. It will be close to something 0.18 or something like that. Okay. So now if you will calculate it, it will come out to be 0.25 multiplied by 0.18. Okay, that will be close to 0.44 something. Okay, so it will represent, it is less common than AI, so it will have more importance. Okay, so this is how, if you calculate each of them, right, this is getting what? 0.44. Okay, now if you see age, okay, for the age it will have some other value, right? You can just calculate, right? So you can, when you calculate for the age, it may come out to be something like 0.1911, something like this, right? Then again for the okay, the also it will come out to be something 0.11, right? So it's like, now this is the encoded version of these 4 words. Okay, this is the encoded or encoded numerical version of these 4 words. Okay, if you have to calculate it using Python, I'll show you. We can just calculate it using Python as well.
Sir, the thing is very interesting.
I'll show you like how actually these things are used, right? So TF-IDF actually helps us in finding out those words which are important. Like, I'll show you just a minute. See, for example, let me create the documents first. Okay, docs is equals to, because if I calculate it manually, it will be very difficult. So let's say AI is the future. Okay, next thing I have AI and ML are the future. Okay. Next thing, let's say I like AI and data science. Okay, something like this, right? Now I have to use this data for model training. Okay, for any purpose. Okay, purpose let's decide later on. Okay, it can be sentiment analysis, it can be anything. But as of now, I have to use this data for model training, right? So I need first this data to be converted into numerical form. Okay, if I am just converting it into 1 and 0, okay, each words are basically picked up independently. Okay, and the size of data is also increasing a lot, right? And it is very difficult in that case to find out which word is important word or which word is not an important word. Okay, if I'm doing it like this thing is not representing the importance of word, right? But now over here, if I will use from Scikit-learn dot feature extraction, I guess feature extraction dot text import, it may be TF-ID vectorizer something. Let me try. If it is wrong, I have to look for the documentation. This function will convert it. First, let it be executed. Okay, so Ajay was having the doubt. I was having a doubt in this only. So let me just search its documentation, the Scikit-learn documentation. Okay, so it is Scikit-learn dot feature extraction TF-ID vectorizer. You can copy it from here, paste it over here, and copy this thing Scikit-learn dot feature extraction dot text and paste it over here. So you can directly pick from his documentation in case something is missing. Okay, no need to memorize it. Only you should know that this is there, this particular thing can be done. Okay, you should know only this much. Okay, rest no need to memorize this thing. You can anytime go to his documentation, can pick from there. Now define an object for this thing, vectorizer. Vectorizer is equals to TF-ID vectorizer. Okay. Now I will use your TF-ID matrix will be equals to vectorizer. This vectorizer, I have to give the information in this thing. All the mathematical calculation that we did, this guy will do the calculation. Okay, I just need to fit and transform. Okay, what I need to fit and transform? The data that we have. Okay, and data sorry, it's a docs, not data. Okay, the docs that we have. All right, now this guy will do what? Will give me the matrix that I can see over here. Okay, compress sparse row sparse matrix of type this one with 50 elements in shape 3x10. Okay, so as it is compressed, so I will use the function called toArray to get it into convert into array. It is
Import numpy, I guess.
So yeah, import numpy you have to use, correct. Okay, import numpy as np. No, toArray is actually,
And even pandas also, I guess.
and oh my god, it's not, underscore is not there.
Okay.
Underscore was not there, just toArray. So now here it's like this is representing my first sentence. Okay, this is representing my second sentence, and this one is representing my third sentence. Right, to better understand it, what can we do? We can convert it into pandas data frame. Put pandas as pd, right, and this is pd dot data frame. Okay, so this is converting to proper structure data. Now we have 1, 2, 3, 4. How many columns? 10 columns. Why? There must be 10 different words. Okay, so now I can give over here columns is equals to vectorizer. If you will just call this guy vectorizer dot get feature names out. Okay, so this will give you, these are the feature, these are the things it convert into numerical form. That means it is doing the same thing. It is also identifying all the unique words, and after identifying the unique words, it is just converting them into the numerical form, but it is not converting them into the numerical form as 0 and 1, isn't it? So it is just converting them as in the form of between 0 to 1, right? So here it's like AI got a value 0.37 in the first sentence, in the second sentence 0.29, and this is 0.29. Okay, and like this, right? R over here is present over here, but it is not present in other sentences, right? So it just converted these things into some values. So now if I have any label, a label can be thing like, suppose there are few sentences here, all the 3 sentences are about AI. Okay, suppose this sentence I use something else, like it is not about, like 2 sentences are about AI, and let's say 2 sentences I use for physics. Okay, physics. Yes. Thing. Okay. And I am interested in concepts of physics. Okay, so like this, right? So now, if I want to create a model which can identify something which is related to some which can identify a document related to AI or a document related to physics. So what I can do, I can give first 2 things can be given a label 1, these 2 things can be given a label 2 or 0, whatever, right? So by giving the label like these 2 sentences are from AI, so it can be given a label 0. These 2 sentences are from this thing, so label 1. So this kind of encoding was also used, right? That is called TF-IDF, right? So it just gives the higher value, or you can say those, like suppose if I have over here 2 sentences, now I can summarize this thing. Okay, now I can summarize it. Let's say if I have 2 sentence, okay, sentence A, I am a cricket player. Okay, B, he is a chess player. Okay, so in this case we have a document 2. Okay, so here in the document 1 we have a cricket, right, chess player, right. So for the document 1, just a minute. Okay, so for the document 1 this will get a higher value, right. For document 2 this will get a higher value, this will get 0 value, right, this will get 0 value, and for player is common in both of them, so player will get lower value for both of them, right, isn't it? Because player is common, so it will get lower value for both of them. So in this way,
TF-IDF.
correct. This is what happening in TF-IDF, right? Unique text are getting higher value and common texts are getting lower value, right? So here this will get higher value, in document 2 this will get higher value, and this will get what? Lower value.
So what will be the maximum value? It will be 1.
Yeah, right.
So value will be between 0 to 1.
Correct. Okay. Right. So in this way there will be a vector created, let's say 0.9, 0, and this is 0.1 something, right? For this guy it's a 0. This is 0, this is 0.87, this is 0.1, right? So in this way, and thereafter we can give it a label and then do further classification related tasks. All right. So this was creating a word vector like this, and in this word vector each numbers are identifying that what are the common words. Like later on, if this will be used to create any model, a model can easily identify, okay, what are the most common words and what are the words which are not common. Based on that, some classifications can easily be made. Okay, so a model can actually identify if some words are very common, so it will not be considered very important, right? And those words which are not common, okay, like in the first thing, if it is label 1, this is not a common word. In label 0, this is not a common word. So whenever those non-common words appear, okay, it will be easier for the model to classify. If common words are appearing, model can't classify well. But whenever non-common words will appear in future for any new data, models can easily classify. Isn't it? Mm-hmm.
So similarly, is it possible to classify spam and non-spam?
Yeah, that thing is done like this only, isn't it? Okay, so fine. So just a minute. These were the things done. Right. Next, I need to explain over here.
Yes, sir.
All right.
Yes, sir.
Yeah, you were saying something?
Yeah, I was saying something. Sir, mathematically that is that is correct, I guess. But sir, I have think about this many number of times, but I haven't got this answer. Sir, let's suppose we are reading a chapter, right? So let's say Swaminathan is a character over there. स्वामीनाथन के बारे में बहुत बार बातचीत हो रही है, तो सर स्वामीनाथन तो उसमें एक इम्पोर्टेंट कैरेक्टर होगा ना, मतलब राइट बट मतलब उस हिसाब से सोचता हूँ तो सर मेरे को आंसर नहीं मिलता. मतलब मैं बहुत बार सोचा हूँ सर इसको, या IDF थोड़ा ऑपोजिट है सर, जो बार रिपीट हो रहा है उसको हम लेस इंपॉर्टेंस देंगे.
Yeah, this is not the only thing, right? We have other things are also there, right? Isn't it? It is not the only thing. It is just one of the way. There are multiple other way which will give the Swaminathan any common words which are, in there is something called named entity recognition, right? Recognizing the names or important places, right? So many things are there, right? When I'll finish everything, you will get the answer of all those things, right?
Yeah.
Okay, so nothing to worry, right? Okay, so what we had seen till now that how sentence basically picked up, right? And what is tokenization, right? And thereafter the different word into numeric form. So let's do some hands-on and then proceed ahead. Otherwise, so many things will be involved over here. So I'll start with the concept of first concept that I'll take as a kind of this one that is called in the hands-on is tokenization and word embedding. Okay, tokenization is like just dividing the whole sentence into tokens, and word embedding is converting those words into the numerical form. All right. Okay, so and one more thing, when you talk about the tokenization can be sub words as well. Okay, sometimes this, most of the time each word is one token, but sometimes this can be one token and this can be other token, that is also there, right? So here tokenization is the process of breaking a sentence or a paragraph into
Words.
smaller units called tokens, usually words or subwords. Okay, so to understand this whole thing, like how sequential data works, okay, the first thing that we need to understand is called tokenization. Okay, and with the tokenizations we will understand over here embedding. So in the embedding, the first embedding that we are going to do over here is called integer encoding or integer embedding. This is called integer encoding.
Is it separate topic from previous, like what we were doing before?
No, the same whatever that we discussed. Okay, same thing we are going to do it practically now.
Okay.
All right, same thing, like all the tokenization I already explained, like what is tokenization, I explained like what is 1 gram token, what is 2 gram token, right? Yeah, so these things we just try to see practically. All right. Okay, so what is integer encoding? It is like after the tokenization, okay, we convert each unique word into integer ID. All right, so that it can be used for predictive modeling or in a neural network kind of thing. Without numeric thing, it can't be done, right? So that is what integer encoding that we do.
So basically, whatever you have shown, sir, that is integer encoding. Whatever encoding you have shown us so far, that is integer encoding.
This thing you are saying?
Yeah, these things are integer encoding, that 0-1 part.
This thing also you can consider as an integer encoding or integer encoding. Okay, I'll explain. Okay, first let me just finish this tokenization and thereafter, otherwise you will get confused, right? So don't worry. So first let's finish this tokenization, right? So let's say I have a text over here. Okay, this text is having multiple text. Let's say generative AI is interesting. Okay, thereafter AI is transforming the world Okay, I want to know about AI more. Okay, so this is what the text. Okay, now I want it to be converted into tokens. So for converting into token, we need to take help of some of the library, right? So here, which library will take help? We'll take the help of a library called Keras. So Keras tokenizer we will use. Okay. So if I search for it, here is what we get. Okay. Now to use it, I need this particular thing, keras.preprocessing.text.tokenizer. Okay. So here TF represent TensorFlow. Now what is TensorFlow? TensorFlow is a framework by Google. Okay. On the top of this TensorFlow, so many libraries for word processing, for image processing actually works. Right. On the top of this framework, TensorFlow, the libraries for image and word processing works. Why they had given it a name tensor? Because this is called matrix.
Start.
Yeah, please tell me.
Sir, we can do it using natural language toolkit also.
Yeah, we can use it.
NLTK.
Yeah, we can use it. Right? So why they have given them tensor? Because if I talk about this thing, this is what matrix, right? But when we work with the unstructured data like text or image, you work with multi-dimensional matrix. Okay, and when we talk about the multi-dimensional matrix, they called it tensor, right? So tensors are basically multi-dimensional matrix. So just to process the high-dimensional matrix, they created a framework and had given it to them TensorFlow. And without TensorFlow, life will be very complicated if you're working with these unstructured data, right? So if I want to use it, I have to import from TensorFlow.keras. Yeah, obviously NLP also can be used, or natural language toolkit can also be used, and we will use that, right? Don't worry. Preprocessing.text import tokenizer. Now I'll see what tokenizer actually do, right? So for the tokenizer, first of all, I have to initialize the tokenizer. So step 1 is initialize. Spelling, why am I doing wrong? Initialize the tokenizer. Okay, then after fit the text on tokenizer. This is what we will do. And third, view the word index. Okay, so let's see. So first, let's say tokenizer is equals to tokenizer. Okay, and thereafter we'll feed over here that how many words. If we can count how many words are there, we can pass it, right? Or we can just use over a number of words. Okay, is equals to. Okay, let's do. I'll not pass anything. Okay, let it blank. Okay, let's do like this. Okay, thereafter we'll check step by step. Otherwise, we'll not understand the effect of it. Tokenizer dot fit on text. But it's not going fit on text. Fit on. So come. Is it changed? Fit transform has been done or what? Fit on text. What texts? No, it should work. Okay, so it text it, and thereafter we'll print over here tokenizer dot word index. Okay, you can see what happened. Here each unique word is identified. Okay, and each unique word had been given one numerical value. All right. Each unique word had been given one numerical value over here, like this, from 1, 2, 3, 4, 5. This is called what? This is called integer encoding.
Okay.
Okay. This is called integer encoding because now with this encoding, you can create the vector for each word. Okay. That means now we can convert text to sequence of integers. Okay, we can convert the text to sequence of integers. That means here we can do what? Tokenizer dot text to sequences. Okay, and I can feed over text over here. Right, if I execute it, let me just use the sequences. And sequences. All right. Now, if you see the first word, okay, the first sentence is having 4 words. That's why it is containing 4 numeric values. 3 is representing generative. Okay, AI. 1 is AI over here, 1, 2, 4. Right. This is the longest sentence, so this is having more number of things.
Okay. Fine.
Okay. So then what happened? It is just converted each of them into the integer form.
Okay.
All right. This is called integer encoding. All right. Okay. Now, you know, the problem, what's the problem with the integer encoding that you see over here? It is generating and giving me what? It is just giving you the unstructured data, right? Now this unstructured data you can't use for the model training, right? So thereafter there is a concept over here that is called padding. Okay. So what we do, we can just import over here one more thing from Keras .utils import pad sequences.
Sir, sir, integer encoding को हम use कहाँ कर सकते हैं एक worst case scenario?
Integer encoding को use we can use it for any type of model building.
Okay.
I'll show you where it is be used. First of all, let's do the encoding. That I'll show you how it can be used, right? But before using, if you want to use it for any kind of model building, okay, the problem is in this form it can't be used anywhere. Okay, because for any machine learning model building or for any kind of neural network model building, it is necessary that your data should be structured. Structured means what? All of them should have equal number of values.
Table format.
Yeah, like it is not like this is having 1, 2, 3, 4, 5, 6, 7 values are there. This is having only 5. This is having only 4. Right? So, you know, machine learning algorithm or any neural network, any deep learning algorithm can't use this data. Okay, now question is why it can't use? Because for any machine learning algorithm, it is important to define the feature size first. Feature size means what? How many features will be used for training? Now you can't say that for the first sample I will give 4 features, for the second sample I will give 5 features, for the third sample I will give 6 features. Okay, if you give it like this, then you know how mathematically it can calculate. Because see, if I talk about any linear equation, so in linear equation also everything is predefined. Right? It is defined that this is a linear equation of 2 variables, isn't it? Now, suppose if you are using a machine learning algorithm, that machine learning algorithm will also use some of the equation, right? So, in that equation will be will get defined, or the variable, the number of variable in that equation will get defined based upon number of features, right? So for every sample, it is not going to change the equation, isn't it? Any machine learning algorithm will not change the equation for each sample. A single equation will be there, and for that equation, everything will be solved. Same way, if I am using deep learning or any neural network, so in that neural network also you have to define the number of neurons for input of data. So you have to define it like, suppose you have defined 5 inputs, right? So for the 5 input, this is suitable. Here 1 will go, here 2 will go, here 5 will go, here 6 will go, here 7 will go, right? 5 inputs you defined, and this will go to the neurons, okay? It will just go to the neurons like this, okay, and try to understand more about this information. Then when second feature will come, or second sample will come, 8 will go over here, 9 will go over here, 10 will go over here, 11 will go, 12 will go, and these will not get any place to insert.
Absolutely.
Right. So that's the problem, right? So, a structured data is required. So for the structured data, what we do, we work on the padding, and whenever we have a data like this, we'll convert this thing into using pad sequences. Okay, let's feed the data over here, sequences, isn't it? And padding can be post or padding can be pre. Okay, so this is post padding, make this structure. All right.
Can we use ML?
Yeah.
No, we can use ML. If we have a thought of like using ML.
Right. ML or any predictive model, any algorithm. This is just preparing the data initially. So either it's image data or text data. It always remain in unstructured form. Before using it for any predictive model, the first step is convert into a structured data. Okay. And thereafter we use it for machine learning model, anything. Right. So, this is one of the thing that we do. This is called what? One of the encoding. Okay. And this kind of encoding, we can use it over here. Like this is called integer encoding, but integer encoding, it's not suggested to use, because here I have just 13 or 14 words. Okay. Suppose I have 10,000 words, right? So last word will get a value what? 10,000, right? Last word, like that means the encoding will be done like this, 1 to 10,000. Okay. So in that case, there will be very challenging situation will happen for the algorithm. Okay. Some of the words are having a very low value. Some of the words will get a very high magnitude value, right? So any algorithm will be using some equation. So it's like forcefully if you give very high value to some of the words and forcefully you are giving very low value to some of the words, it's like forcefully you are increasing the importance and decreasing the importance of some of the words, right? So that's why integer encoding is not that much preferred. Okay, but integer encoding, with the help of integer encoding, we move next step. Okay, that is used for the next process that we'll discuss tomorrow. What happened? Suppose you did the integer encoding. After integer encoding, you get a value like this: 1, 2, 3, 4, 5, 6. Now these will be converted into vector. Okay, this will be converted into vector like this: 1, 0, 0, 0, 0, 0. Okay, and this will be converted into vector like this.
Sir, this is one hot encoding.
Correct. From integer encoding, one hot encoding will be done. Okay, and from one hot encoding, one word embedding will be done. Okay, so this is step-by-step process actually. So integer encoding. So from our integer encoding, we did one hot encoding. But again, the one hot encoding is like creating the vectors, right? Now these vectors are having one value, one, rest all are 0, right? So the problem of that thing is solved. Like some word got a value 10,000, some word get a value 20,000. That thing is solved. all the words will get a value either 1 or 0, right? Okay, but a new problem came over here. The problem is size of this vector. If I have 6 unique words, the size of vector is 6. If I have 20,000 unique words, the size of vector will be what? 20,000. Correct? So that vector size increases. Next, each of the vector are having only one value, one rest all are 0. That means all the vectors are at 90 degree to each other. Right? That means if I have a word like nice and I have a word like good. So nice and good are are similar words. Right? So I want my system to identify them similar. Right? So what I want, that means if there is a vector representing good and there is a vector representing nice, so they should have very
less
angle. Okay, then only your system can understand, okay, these are the similar words, right? So how that can be possible? That can be possible by converting them into a vector through word embedding, okay, where these all things will be converted into a vector like this: 0.12, 0.33, 0.45, 0.62, 0.15 kind of thing. Okay, these kind of
पैडेड सीक्वेंस एक बार बता देंगे. ये पैडेड सीक्वेंस तक तो पता लग गया, इंटीजर एनकोडिंग हो गया, पैडिंग हो गया. उसके बाद ये हम यहाँ when we come to this, like you know this you are showing this one hot encoding thing.
One hot encoding.
ये तो इसके अंदर ही होगा ना, पैडेड सीक्वेंस के अंदर 3, 1, 2 के अंदर आएगा ये, कि अलग से कुछ है ये, मतलब जो 3 है यहाँ पे अभी 3 के अंदर ये आएगा क्या कहते हैं वन हॉट एनकोडिंग, कि ये बाहर होगा वर्ड के बेसिस पे? यहाँ पे थोड़ा कंफ्यूजन हो गया मुझे, सॉरी.
नहीं लाइक ये ऐसे होगा लाइक ओके फाइन, आई विल एक्सप्लेन. यहाँ लाइक दिस विल बी डन लाइक दिस. वी हैव
पैडेड सीक्वेंस द क्लियर है मुझे.
अंडरस्टूड. सी हियर दिस विल बी कन्वर्टेड इनटू लाइक ओके, एक काम करता हूँ तो मैं सिंपल करता हूँ इसको. लाइक जस्ट अ मिनट, आई जस्ट ट्राई टू मेक दिस थिंग इजियर. लेट्स से let's say I have this was the words like I am a cricket player, right? So I am a cricket player like this, right? So it will get a encoded value like this: 1, 2, 3, 4 and 5. All right, integer encoding. Now this will get a value 1, 0, 0, 0, 0. Okay, why 5? Because only 5 unique words are there. Okay. So here now unique words will be picked up from whole data, not from a single document. Unique words will be picked up from the whole data, right? Please do take care. Here it is the complete data. From these whole data, the unique words are picked up. All right. So if from the whole data you have 10,000 unique words, so it will go up to 10,000. Okay.
How it is related to padded sequence? Is there any relation between this and padded sequence?
Okay, I'll explain. So see, now this is done. Okay, now the sentence you have over here, like if I have a sentence like this: I am a cricket player, right? So this will be represented like this: 1, 2, 3, 4, 5. And now it will be represented like this: 1, 0, 0, 0, 0. Okay, now it will become a matrix. Okay. Okay, 0, 0, 0, 0, 1. Okay, now it will create a matrix. So this particular matrix is representing this data. Okay, now what you were saying, like padded sequence, like I didn't understood.
So I go like follow it till padded sequence. That okay, we got the integer encoding, it makes integer, and then we do padding, and we got this nice matrix, which captures our whole sentence, whatever our data set is. Our data set is in this padded sequence now. So now, how the jump happened from this to encoding? वो पे मतलब example था इसका जो word थे वो आपको type.
This is a padded sequence in a 2-dimensional form, right?
Yes.
Now, when you convert this thing into, this will be converted into what I said, one hot encoded form first. Okay. So the one hot encoding will convert into 3-dimension. Okay. It means here, this will represent your first set of data. first set of data, let's see 3, 1, 2, right? So it would be like this: 0, 0, 0, 1, 0, 0, 0, 0, 0, right? Thereafter 1, 0, 0, 0, 0, 0, 0, 0, something like this. Okay. Thereafter 1, 0, 1, 0, 0, 0, 0, 0, like this. Okay. Then after 0, 0, 0, 0, something. Okay, like this, right? And thereafter 0, 0, 0. So this will continue over here. Okay. It would be like this. 0 is represented like this: 1, 0, 0, 0, 0. Okay. 1 will be represented by 0, 1, 0, 0, 0 kind of thing. Okay. So 2 will be represented by 0, 0, 0, 0, 0, 1, 0, 0, 0 kind of thing. Okay.
First row will become a matrix. First row will become like, instead of row, it will become matrix, like you are.
Correct. It will become a matrix. Okay. And second row will again become a matrix. Okay. Third row will again become a matrix. So overall, it will become a 3-dimensional data.
Okay. Got it.
Okay. So this will be done. But after this, this whole thing will go to neural network. Okay. To create your word vector in which each word will be represented by a float value. Okay, so that will do. But as of now, I'll just conclude over here with a thing like by explaining whatever that we covered. See, whenever we are working on a text data, so text data needs to be converted into numerical form. That is the first step. Now, to convert a text data into numerical form, what we want, we need to know the concept of tokenization. What is tokenization? Tokenization is like converting each word into like breaking the sentence into small into each small units, which can be a single word. Right now, initially this was the thing which were used. Okay, in which whole document is converted into a structured data like this. But here each word was considered independently, or it was kind of a uniquely. So relation between words was not getting done, and next it was creating the very huge set of data for the training. Okay, even with a small size document. Okay, even with a small size document, the data for training getting increased a lot. Right? If you already have a large size document, that's fine. But for a small size document also, it was creating a very large size data. Right? So this was not feasible for so many reasons. Right. So thereafter, so many technique people had given. Okay, like TF-IDF came, 1 gram, 2 gram kind of thing came. Right. Thereafter, this process was continued. Okay, to convert the words into numerical form. Right. Then this thing came like we can also convert into integer form. So now integer form is created. After integer form of the word is being created, it is being identified that what can be the words are so many millions of words are there, right? So you can't give millions of value to the things, millions of integer value. So that will again be a challenging. So something we have to do. So thereafter, word embedding is introduced, in which we are converting the integer form of the words into the vector form, and those vectors can easily be used to identify the relation between multiple words. So tomorrow we will work on it. We'll try to convert this thing into the vector form, and thereafter we will use it in the neural network, and we'll see how these vector forms can be used for the training purpose.
Okay.
All right. Is of what we covered in last class. In last class, we mostly worked upon the words. We just tried to understand how computers can learn from your words. Okay, because to generate the words, first it needs to learn from it. Right. So how will it learn from it? So to learn from it, first of all, your sentences will be breaks down into smaller units, which are called tokens. Each word will be called as a token. Thereafter, these tokens will start getting encoded. Can you see my screen?
Yes, sir. Absolutely.
Okay. They will start getting encoded. So for the encoding, we have multiple ways to do the encodings. Right? So the first, in the very initial stage, in the year, you can say when this all thing started, okay, you can consider by the year 2012 or 13, when people started working on these kind of technology. So the term that has given was bag of words. So bag of words was kind of for this kind of encoding. Here I have a one sentence, and here I have a other sentence. Both the sentences are having different sentiments. Like first sentence is having a good sentiment and this is having a poor sentiment. So we just label the first sentence as 1 and second sentence as 0. Now we want to train a machine learning model which can identify a sentiment. So what we do, we just consider them as two different documents, right? Now from both the documents we pick up over here the unique words. Okay, from both the documents unique words are picked up. Like I am a good cricket player, then Raju is A is not picked up because A is already there. Okay, bad chess again player is not coming up because player already picked up, right? And based on that this encoding is done, right? So now in the first document we have these words are there. So whichever words are there in the first document, like I am a good cricket, those are 1, rest all becomes 0. In the second sentence, whichever words are there, they becomes 1 and rest all are 0. And this is a label. That means to train a machine learning model, we can use this thing as a X, that is your feature, and this is Y. And thereafter, any machine learning algorithm can find out the relation between X and Y, right, to predict Y later on. Okay, that is what we can do. Now we do what? So this is how encoding can be done, and to do this encoding we can make use of this Python script, right? So what is this Python script? This Python script actually we could not do in the last class because I guess I told you about other, but this one I had skipped, right? So let me just do it today. Okay, this is what bag of words things, right? So what it does, here we are using the inbuilt Python library which is called Scikit-learn for the encoding. This is what? This is TF-IDF, right? So before TF-IDF I should do it. So we are just using over here the inbuilt Python library, and the inbuilt Python library is what? Count vectorizer from sklearn. Alright. And when we are doing this thing, this library will take care of the encoding part, right? So we just take the count vectorizer and thereafter we need a data. So data is already being defined here. Let me just pick up the data. If you want other data, you can also use it. Here just 2 sentences we have. Okay, it can be 3 sentences, 4 sentences, as many sentences may be there. So based on all, like suppose if you have 3 sentences, so for 3 sentences we have more number of unique words, right? If you have 4 sentences, you have more number of unique words, right? So if you have suppose 1000 sentences, you may have 100 unique words. So if you have 100 unique words, in that case, this will create 100 columns, right? Right now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 unique words in 2 documents. In 2 sentences, I have 11 unique words. That's why 11 columns are there. If it is 100 unique words, 100 columns will be there, right? So for that, we are using this Python thing. Thereafter, fine, this is done. And thereafter, we have to do what? We have to just pick this thing that is count vectorizer. That is an inbuilt library. There's nothing to do. Okay, this library will do the job and just pass this data to this guy. Okay, not this guy. Just define the vector for this guy. Okay, sorry, the object for this guy, and then we'll feed the data. We just call this object, right? And with this object, we'll call a method defined within it. Okay, and the method is what? Fit transform. Okay, this fit transform method we will call and fit the data to this guy. Okay, that's it. Right. Now when I execute it, let's wait for the time so that it can connect with your server, this Google Colab. Okay, so we are using Colab. So Colab actually, colab.research.google.com. This guy is a cloud-based tool for coding, isn't it? So this guy automatically gets connected with your Google server and gives you some amount of RAM and disk space, right, to execute your code, right? So it takes some time to connect with the server. Now it's connected. Now I can execute it. So when I execute it, you can see it is showing me some like compressed sparse flow. That means it has generated the output. Okay, and as it has generated the output, how can we visualize the output? To visualize the output, let's say I will store this thing into bag of word matrix. Okay, and then if I call bag of word matrix dot what to array. Okay, so it will convert our output into array. So this is what we got. Okay, and then after we can convert this thing into data frame, pd dot data frame. Now what is pd? It is pandas, isn't it? So there is a Python library that is called pandas library. Okay, this guy do what? This guy take care of all the structured data. If you have any structured data is what? Like, you know, Excel data is a structured data. So in Python, pandas is just like your, it works like your Excel. You can say this is Excel for pandas. Right? You just convert a matrix into a proper structured data frame in which each column will have a name and each row will have a name. Right? But your column is having a name as 0, 1, 2, 3, 5, 6. Right? I want column to have a, like, you know, this thing should be, I want output like this. Okay, where I am good. This one should be mentioned. Right? It is giving 0, 1, 2, 3, 5, 5, 5, 6. So what I do over here? See, when we have this vectorizer, yeah.
Oh, sorry. Actually, I had connected with different computer, my laptop, and when I was speaking, I think no one was hearing. So I changed the laptop. So I just wanted to check. Sorry.
Okay. Fine. So here vectorizer is an object in which we fit the data. That means vectorizer object is actually known to all unique words. Right. So we can take the vectorizer object. I'll show you. Okay, after this, if I just print vectorizer dot get feature names out. Okay, this is the inbuilt method to read the feature names. So this guy actually knows all the feature names, all the unique values. So these unique values I want to assign to this data columns. So what I can do, I can just call the columns parameter over here. And this columns parameter can be equals to this guy. Right, that's it. Alright, so they got their things. Now this is commented.
Hello?
Please tell me.
Sir, should I memorize all the code as it is? Because
no need to memorize. See, these will be used for repeated number of times.
Okay.
So you will be automatically get used to it. Right, but you don't need to memorize this thing. Reason, we are using library. You should only know that there is a concept called bag of word. There is a concept called TF-IDF, right? Bag of words. So bag of words is a concept word. It is used to convert your words into numerical form.
Yes.
Okay, words into numerical form so that your machine can learn about it, because machine can only process the numerical data. It can't process text data. So text data can be converted into numerical form by certain means, like bag of words. Now you know this concept. Now whenever you have to use it, you don't have to memorize this code. You can just go to Google here and can search for bag of words, right? And sklearn, right? Because sklearn is a library which is containing all these things, right? So when you search for it, you will automatically get a here documentation. Okay, when you click on this documentation part, you get every detail of it. Like you just nothing. Please don't read all these things. Okay, no need to read it. Just scroll down and see how it is used. Okay, so it is saying first import this thing. So same thing we imported here, right? Next, it is saying that you need a text. So we already have a text. Next, it is saying that you need to define an object. For count vectorizer, we also defined the object here, right? Next, it is saying what? That you need to fit transform. Fit transform will do what? It will do the transformation of your data. Okay, so this will just transform your data into numerical form by identifying unique values. Okay, and this will give you all the unique words. Right? And this is your array. The same thing we did. And this array we just converted into what? Into the pandas data frame using pd.data.
Sir? Hello?
Tell me.
when we are using ChatGPT also, if we give prompt to ChatGPT can also generate that kind of code. So
yeah, obviously, ChatGPT can also help you. Only thing you should know that what are the terms,
yes.
right? If you know the terms, then documentation is there, ChatGPT is there, through which you can you can take the help.
Sir, just asking one thing. Just say when we are going for the company interview or after selection, we will start working at a company. Is it allowed that we can take the help of ChatGPT or documentation for writing code?
Documentation, obviously. Documentation will always be allowed because code will, it's not like that you can, because these are, there is called logic building, right? And there is called that when you use a library, right? So library, it's like you are using someone else's library, so you have to follow the rules of that library. Now, how do you learn about those rules? Obviously, the documentation of that library, right?
Yes.
So no one can ban the documentation part, because if documentation is banned, you can't know that how to use something. Right? Like suppose you buy a product, so in that product there is a product manual used to be there. If someone says no, you don't have to use product manual, just use the product.
Okay.
So library is like that product manual, right?
Okay.
So obviously, but yeah, ChatGPT is something which may be banned at many institutions. Reason being, ChatGPT is using internet and no one knows. Like suppose you are working on an institution in which there is a very highly secure data is there. Right? And you are just copying and pasting here and there. You just take the data, pasting in the ChatGPT, asking the output from it. So the data may get compromised, right? So that's why ChatGPT may be banned in many organizations, but documentation no one can ban, right?
Okay.
Because right, so logic something you can build, but rules you have to read from somewhere, right?
Okay.
Now next vectorizer, that TF-IDF vectorizer, that already, so this is a vectorizer through which you can convert the words into numbers. The problem with this particular kind of vectorizer is what? If you have very large number of unique words, the data size increased a lot. That creates a problem while training the model. Second, here each words are considered uniquely, separately, so there is no relationship your model will learn between the word. That means no pattern will be identified. Right? Like here, after player Rajiv is coming, right? So, what is a pattern? Rajiv player, it's meaningless thing, right? So, the data pattern can't be identified by your model because each word are considered individually by your model, right? Your machine learning model. Next came TF-ID vectorizer. What TF-ID vectorizer is doing? TF-ID vectorizer will give the value between 0 to 1 based upon like how frequently a word is used. Okay, if a word which is used for so many times throughout the document, like AI, right? So it will get lesser value. It is 0.50. Why it is 0.50? Because out of 4 words, it is used for 2 times, right? So like that, and here it is getting 0.35. So why it is not getting 0.35, 0.50 over here? AI is same. AI is there. So here AI is 0.50. Here,
but the document is different. Document is different.
Right, because here the document length is different. So now it comes the next thing that is called your this one that is called integer encoding. Right. So with the integer encoding, first what we did, we just consider each word. We had given the each word as one of the numerical value. All right. Each word is given a set of these are the words. Now, out of these words, all the 8 words are identified, and they have been given an integer value over here. All right. Okay. And based on the integer value, when we create a sequence, this is the third type of encoding. First, it was bag of words. Second, it was TF-ID, and third, now we are using what? So now when we use TF-ID and when we use bag of word, that I also had mentioned over here. Bag of word is very simple. It is more sophisticated. It is binary based on term importance, like which word is important, which is less important. It will give you the equal importance to each word. It will not give equal importance to each word, right? It is like ignored. Like if there is a word which is unique, it will be ignored, right? But here, if there is a unique word, it will get the higher value, right? TF-ID will give it the higher value, right? So that is the difference between these two things. Now, integer encoding is what? Integer encoding is like just encoding it as an integer value, right? And based on the integer value, you can, like, suppose here it is an integer value is being given to your document. Like you have a document in which these many words are there. So each words had been given an integer value, and based on the integer value, we create a sequence of vector, right? So this is a vector representing your first sentence, this is a vector representing second sentence, third sentence. But when you create such kind of vector form, your data becomes unstructured, right? Unstructured because why it is unstructured? Because first sample is having 4 values, okay, second is having 5, and third is having 6 or 7 values, right? So when a data is called structured, a data is called structured if all of them will have equal counts, right? This is called structured data, right? So just to make this thing a structure, next step what we do, we follow the padding. So here post padding we are using, so that whatever places where we don't have the value, they will become 0, right? So integer encoding is it is non-hard encoding, non-bag of words, and it is just kind of a normal. So this is what we did, right? Now we have to understand this part. This is what I had not explained yet, right? So what it will do, isn't it? So let's try to understand this thing. Okay. So up to here we did our encoding part. Let me just execute it. Okay. All right. Now, these things. Okay, fine. So after this, what we should do? We have to. Okay. So now, what happened? Here we have the unique values identified. Now we have to convert them into the word vector. Okay. What is word vector? Word vector are basically the vector form of each word. Okay. Now, what is vector form of each word? See, as of now, whatever we did, okay, like either we used what, or bag of words, okay, or we are using TF-IDF, okay, or you are using what, integer encoding. Okay. In all of these things, a single word is getting one value, isn't it? Like AI is getting a value 1 or 0, right? In bag of words, right? In TF-IDF, what it is getting? It is getting some value between 0 to 1, right? For each word, the value is different. Okay, for each sentence, the value of AI is different. For the first sentence, it is 0.50. For second sentence, it is 0.35, right? Right? Now, in the integer encoding, AI is getting a value what? AI is getting a value 1. Okay, if you see, AI got a value over here 1, isn't it? AI got a value 1, right? So here, whatever the things we did, each word is getting one numerical value. Now, if you just give the numerical value, lot of things can't be done. Okay, like for example, yesterday I told you if 2 words having the similar kind of meaning, like nice and good. Okay, and suppose nice get a value as 7 and good get a value as 21. Okay, so how model will know that these two are, having the similar meaning, right? So that's why the concept of word vectorization came. That means convert these words into the vector form. Okay, that means each word will be represented by a vector of numbers. Okay, a vector in which multiple numbers will be there. Okay, 0.22 kind of thing. So this is what? A vector in which multiple numbers are there. As each word will be represented by a vector, that means each word will get a direction. Because vector is used to have a direction, right? Like this, right? So as each word will get a direction, it means what? It means now by calculating the angle of difference between the vector, model can easily identify that, okay, these two words are having a similar meaning, or these two words are very close to each other, and some of the words are not close to each other, right? So this process is called word embedding. Okay, so now let's try to check how actually word embedding happens. All right, so over here for doing the word embedding or converting it into a vector, what we do, one of the most simplest way of word embedding is what it is called one-hot encoding. Okay, it is called what? One-hot encoding. But again, one-hot encoding is something which will not help you in understanding that how each word are related to each other. Okay, what is one-hot encoding? Let me just try to explain it. So for one-hot encoding, what I do, first of all, let me make it more simple. Okay, let's say here I take a sentence. Here I just take a simple sentence because I have three sentences are there. I'll make it two. I am playing I'm playing cricket. Okay, and here I'll do what? I'll make it he is playing chess. Okay, just two sentences so that things can be easier to understand. Okay, so this will be first converted into numerical form like this. Now based on this numerical form, we got this thing, right? That means this is representing first sentence, this is representing my second sentence. Now we did what? We just, with the help of inbuilt library called Keras, we converted into a sequential data, right? Now what one-hot encoding does? One-hot encoding, we have seven values over here. So one will be converted into 1 0 0 0 0 5 6 7. Okay. Two, actually not this one. Okay, there is one more thing called 0. Okay, that will appear first. 3, 4, 5, 6, 7, 8. Okay, and this will be like this. Okay, and then 2 will be converted into 0 0 1 0 0 0 0 0. In this way things will go on, and 7 will be converted into 0 0 0 0 0 1 2 3 4 5 6 7 8, like this, right? Now based on this, if you convert this data, okay, what will happen? It will be like this. This is 2.
In integer there is no 0. It has been started from 1 only.
It will start like, why 0 I consider? Because suppose here some of the sentences having just 3 words. Okay, like suppose if I have a sentence over here called having 3 words. Then suppose please yes. Okay, so here I have only 3 words, right? So now if I use padding, there will be a 0 automatically added, right? Isn't it? Are you getting it? So as 0 is automatically added, so what I need to do?
Oh, for padding 0, this 0 is considered.
Correct.
Okay, I'm getting.
Yeah. As we are doing it kind of if it is non-structured data, then obviously 0 will come, right? So there should be some vector which is representing 0, right? Understood? Am I clear?
Yes, sir, absolutely.
Okay, so this is what we are doing now. If we have this thing, that means each word over here will be represented by a vector, right? This vector will be like this, right? So here I have how many? 7 words, right? So 7 words, 1 2 3 4 5 6 7, and 1 is representing 0, right? That means now this thing will be represented by a vector like this. Okay, over here 1 will be represented by what? 0 1 0 0 0 0 3 4 5 6 7 8, right? And 2 will be represented by this, right? 3 will be represented by, okay, and then 4 will be represented by 0 0 0 1. Okay, and thereafter this is the first thing. Okay, this whole thing is representing my first sentence. Okay, then second sentence will be represented by what? 5 6 7. So 5 is what? 5 is like 0 0 0 0 0 1 2 3 4 5 6 7. Okay, and this will, it will go on. Okay, right? 0 0 0 0 0 0 0 1, and then I have a 0, so it would be what? 1 0 0 0. Okay, so in this way each sentence we are representing in a form of matrix, right? And each word is represented by a vector. This is called what? One-hot encoding. All right, So now what is the challenge of one-hot encoding? Can anyone tell me?
So many features.
No.
Size, dimensionality.
No. Here the thing is,
every feature will get equal importance. So model will not be able to give the importance to anyone.
Correct. Yeah. Correct. Every feature will get the equal importance. And second thing, all the vectors, right, are like this. Like if I will have a vector like this, 0, 0, 1, 0, 0, right? And there is a vector like this, right? 0, 1, 0, 0, 0, right? So here these two vectors are 90 degree to each other. Isn't it? So it is a 90 degree to each other. You know, the relation between words will also be difficult to identify. Okay, but this is the initial stage that people thought, okay, we can convert this thing into the vector form like this. Okay, so let's say if I have to convert into vector form, how can we do it? We can just make use of Keras. So from Keras dot utils import to categorical. This is the inbuilt function which will take care of this thing. Right, so we can just take this to categorical, okay, and pass this padded sequence to this guy. Okay, then we get the output as I said. Right, that means this is representing your first word, this is representing second word, third word, and fourth word. Right, so this whole thing is a sequential data which is normal sentence. This is being converted into a vector form. Okay, but here the challenge was same. One of the challenge that you said that if you have suppose 1000 words, then this vector size will become 1000, right? Isn't it? That is one thing. And second thing, it will also be difficult to identify the relations between the multiple words and all. Isn't it? So there are multiple embedding techniques here. Okay, one of the embedding technique that we will use over here is called Keras Embedding. Okay, thereafter there is an embedding technique which is called what? Anyone heard about it? Word to vec?
No, sir.
So, word to vec and globe.
Globe is also, yeah, right. Globe is also embedding technique. Okay, so these are
and CBOW are word to vec.
What happened?
CBOW and skipgram are two.
Yeah, correct. A lot of embedding. I'll go deep dive into it, right? So there are a lot of different embedding techniques are there, right? Now, if I talk about this thing, that is your what is this? Keras embedding. Okay, so Keras embedding is basically a supervised learning process. Okay, now you may not be, if you don't study machine learning, you might not be knowing about supervised learning. So I'll give you a higher level understanding of it. What is supervised learning? See, if there is a project going on, right? So in that project, what happened? There used to be a supervisor. Okay, there used to supervisor. With the supervisor, there are so many team members who works. Okay, like so, what supervisor does? Supervisor, the role of supervisor is to give the instruction, to get these, to get the give the instruction to finish the project. Why supervisor gives the instruction? Because supervisor knows the expected outcome, right? So this guy gives the instruction so that these guys can get the outcome, and then after this outcome gets compared with the expected outcome by who? By the supervisor. Okay? And if this outcome is not close to the expected outcome, again fresh set of instruction came, right? And again, so the role of supervisor is to make sure that this can be as close as to expected outcome. In supervised learning, same thing happened. The algorithm knows the expected outcome output for each sample of training, for each sample of data that we are using for training.
Sir, may I ask you one question?
You can ask. Please let me finish it. Right?
Okay.
Let me finish it. So in supervised learning, for each sample of data, right, algorithm knows the expected outcome, right? Now, based on the expected outcome, the algorithm try to learn about this sample data, learn about the pattern in the sample data, so that expected outcome can be achieved. Okay, so what algorithm does? Algorithm try to learn about the sample data so that expected outcome can be achieved, right? So when it will try to learn about the sample data, it just understood the pattern which can gives it the expected outcome. That is called supervised learning. Right? So supervised learning is a process in which expected outcome is already there in the data. Okay, with the data, expected outcome is already there, and with the help of that, model actually learns. Right? Yeah, Abhishek, please tell me.
Sir, when you are teaching me word embedding, sir, if you please tell me the difficulty of the word embedding. It is basically too difficult to get the similarity between words.
Yeah, we'll discuss. Don't worry. Okay, we'll go step by step. Okay. So now, how can we use the Keras embedding? Keras embedding will be there to convert these things into the word vector, right? So let's try to convert this thing into the word vector. So for that, first of all, I have to use from Keras import models, and two things I have to import. One is models, other is for layers. Okay. Now, what is models? Okay. So models is a inbuilt. See, two libraries we'll use a lot. One is called Scikit-learn and other is called Keras. Okay. So when we use Keras, this is a library which is used for mostly deep learning kind of things. So do you need to go through the deep learning part as of now? You don't need to go deep learning part as of now. I'll give you the understanding, right? So here, generally, whenever you use Keras, we basically use it for creating the model. So when you want to create a model, we make use of these two things. One is called model and one is called layers. Models is used to define that what kind of models you want to create. Okay? There are two kinds of functionality it is having. One is called sequential model, okay, another is called functional model. Okay, that you can create. Right. Now, what is sequential model? It's like everything is attached in a particular sequence. If everything is attached like this is called sequential. Okay, that means first this will happen, then this will happen, then this will happen, then this will happen, then this will happen. Okay, functional is what? Like, if you create some kind of a complicated architecture, like, this, like this. Okay, that means to affect it, okay, these two are affecting sequentially, but we have one more branch, okay, that is also affecting. Okay, like this. Okay, so when there is a complicated architecture created for the learning process, that is functional. Okay, so here that is what models define. Okay, that means you are going to create a sequential architecture for a simple job, or you are going to create a functional architecture for a complicated job. Right? And what layers does over here? Layers are used to define the layers of training. Okay. Now, what is layers of training? See, Keras will be used to create your neural networks. Right? Now, what is neural networks? Right? See, neural networks are just the same thing that we use in machine learning, but little bit for more complicated kind of data or for large scale data. Okay, you can understand neural network like a multi-story building. Okay, if machine learning is a one-story house, just one floor house, neural network is multi-story building. Same thing, but will be used in layer format. Okay, so what happened in machine learning? Machine learning, you define a kind of a formula, right? That formula is called algorithm, right? You feed the data to this formula. This formula, when you feed the data to this formula, right? Thereafter, there used to be a label, right? Now this formula will calculate the output, right? And when it will calculate the output, the error optimization process of machine learning will try to minimize the error between the existing output and the calculated output. Okay, by changing the coefficient in this formula. That is machine learning, right? In deep learning or neural network, what happened? This process becomes kind of a more intense. Here we feed, like, say, suppose what happened. Let me just try to explain with a simple example. Suppose I have kind of a situation let's say, okay, fine. Let's say I have a situation like advertisement cost. Okay, so suppose I am advertising on, let's say, on TV, and I'm running my advertisement on, let's say, social media. Okay, and let's say I'm running my advertisement on, let's say, hoardings and banners, right? And then after I am getting some sales, right? Now let's say here the advertisement cost on the TV is 32. On social media, 32,000 or something you consider. It's like 10, again 20, again some sales values are there, 50. Okay. Now it is 62, or let me make it. Let's say it is 5, 7, 3, 10. Okay. 2, 8, 9, 20. 3, 7, 8, 5. Okay. So what machine learning will do? If we'll go for the very simple approach. Machine learning will define a formula. That formula, let's say, linear formula. Okay, so this is a linear formula defined. Okay, x2 plus w3 x3, where x1 will be replaced by what? w0 plus w1 into TV plus w2 into radio plus w3 into hoarding or banner. Right now, now what happened? Here there will be some values of weights will be defined, right? Okay. Let's say weight I am defining as 1. Here also I define 1. 1 multiplied by 32 plus 1 multiplied by, what is it, 10 plus 1 multiplied by 20. I just define 1, 1, 1 because I don't know the weights value. I don't know the weights value, so I just define some weight value from my own choice. So based on that, if you calculate, it will be what? 20 plus 10, 30, 30 plus 32, 62, 62, 1, 63. Right? So calculated value over here is what? 63. Right? So there is an error between these two entities. Okay, what is the error? 13. So this error needs to be tuned, needs to be decreased. So how these error can be decreased? This error can only be decreased by changing these weights values, right?
So optimization.
Okay, you can't change these values, right? Because these are coming from the data. Only weights value you can change, right? So there is an error optimization process which will actually change these weights value, so that if sales is your y, so that y minus y hat can be minimized. Okay, so in machine learning, the algorithm try to minimize this error, okay, by tuning these weights values. Okay, and these weights values are called what? Trainable parameters. So in this thing, how many trainable parameters we have? We have 4 trainable parameters, right? Okay, so only 4 trainable parameters are there, and suppose I have thousands of data, so only those 4 trainable parameters should be set in a way that for all the data, this error can be minimum. Okay, these 4 parameters should be set in a way that for all the data, the error can be minimum. Right? Now, if suppose this number of trainable parameters is not enough for me, okay, I have only 4 trainable parameters, but I think no, this is not enough. I want more number of trainable parameters. So what can I do here? If I want more number of trainable parameters, what I can do? I can just go for neural network. I'll show you how. For neural network, what happened? I will define input neurons. How many input neurons? 3 input neurons. First input neuron will capture the TV component. Second will capture the what is this? Social media component. Third will capture the hoarding component. Then there is an output neuron, right? So if I directly connect them to calculate the output over here, okay. So this is my weight. Okay. So condition remains same. Weight 1 into TV plus weight 2 into radio. Social media plus weight 3 into hoarding. Condition remains same.
Sir, one bias.
Yeah, bias is already added here.
Okay.
Right. So W0. Condition remains same. No change. Right. So now what we do? We basically add over here a hidden layer. And when you add a hidden layer, this thing becomes a neural network. Okay. So with the hidden layer, what exactly happens? Let's see. This is a hidden layer added. Now the output will be calculated not directly. First, algorithm will calculate the output of hidden neurons. Okay, so if you calculate the output of hidden neurons, so how many weights will be there? 3 weights over here. Okay, 3 weights over here. Okay, so it is W0 1 plus W1 into TB plus W2 into social media plus W3 into codings. And here it will be what? W02 plus W4 into TB plus W5 into social media plus W6 into coding. Right? And then this will be what? This is W7, W8, right? So W03 plus W7 into H1, that is hidden neuron 1 plus W8 into H2. So if you are using a normal machine learning model, you were having 4 trainable parameters. But now if you will use neural network, how many trainable parameters are there? 4 over here, 4 over here, 3 over here. So it is total 11, right? So that's the purpose of neural network. Okay, the purpose of neural network is to increase the number of trainable parameters. Now when y hat will be calculated, and the process of calculating y hat is called feed forward process, because first we calculate these guys, then you are calculating this one. So it's a feed forward process, right? And once y hat is, yes, just wait, let me complete. Okay, so yeah, I'll take your query, just 2 minutes, right?
Okay.
So during the feed forward process, your y hat will be calculated. Thereafter, there must be real cells. Okay, right? So y minus y hat can easily be calculated. That will give you error. Okay. Thereafter, the backward propagation triggers. Backward propagation do what? Will change the values of these weights. Okay, through error optimization. Right, backward propagation will change the values of these weights through error optimization, so that your error can be minimized, and an error can only be minimized by tuning these values of weights. Understood? So that is called backward propagation. So neural networks, as of now, that error optimization and that process is different, because that is totally different study. How error get optimized, gradient descent, Adam, RMS prop, so many processes are there. No need to go in that direction. I had given you this understanding so that you should know what is neural network and what neural network actually does. Neural network just increase the number of trainable parameters for any particular situation. Number of parameters that your machine learning can learn, okay, a number of parameters in the same situation neural network can learn can be a very big difference. Like over here, machine learning can only learn in the same data. Machine learning can only learn 4 trainable parameters. That means 4 parameters a machine learning model can tune, and with those 4 parameters, a machine learning can try to find out the relation between x and y. Right? What is the best relationship between x and y? But here it will identify 11 parameters, and with the 11 parameters, it will try to find out the best relation between x and y. So what exactly you did? You basically, if machine learning model size is this one, then this will be the size of neural network model size. Okay, that is a basic understanding of neural network. So right here, we are going to use the embedding to these 2 things. Models will define that we are going to use sequential model for embedding, and layers will define different layers, like it's a hidden layer, input layer, output layer for the embedding. Alright, now you can ask a question, please tell me.
Sir, what I am asking, when we are creating a neural network model, there are number of hidden layer and number of neuron per hidden layer. How should we choose the number of hidden layer and number of neuron in a hidden layer? It is randomly chosen.
No, that is actually chosen based on the performance of a model. Right? Suppose you created a model and you are, using a lot of hidden layers. So see, let understanding over here. See, suppose if you have input, this is the input neurons, right? And if I'm using two hidden neurons, right? So number of weights will be what? Here number of weights will be 11, right? Right?
11.
And if I will do like this, I just use like this. So what increases?
Number of weight will be
weights. Number of weights actually increases.
absolutely.
Right. So size of model increased. Right. So when you are increasing the number of weights, actually you are increasing number of trainable parameters.
Absolutely.
So when you increase the number of trainable parameters, there is a chance that your model may becomes overfit. Okay. Overfit is a situation in which model knows too much about the known data. Okay. That means for the known data, it becomes extremely good. But when something new entity is coming, it is not performing well. Okay, so when you keep increasing the new these things, okay, so what do? You are actually increasing the number of trainable parameters, so that may create an overfit. So we just, after building the model, we just evaluate it. If it is overfitting, then we decrease the number of hidden layers or hidden neurons. Or we use so many other things, like we use dropout, we use regularization, we use batch normalization. So many other techniques are there to control it. But anyway, like when you when we discuss in detail neural network with you, I will explain those. As of now, I'm just trying to explain you what is neural network, because the thing that we are going to do for that purpose, basic understanding of neural network is important.
So sir, basically as per the accuracy of the final result, we have to adjust the number of hidden layer and number of neuron.
Correct. It is not just accuracy. It is about accuracy of model on the training data and test data. Suppose accuracy of training data is coming out to be 95% and test data accuracy is coming just 80%. Right? So there is a good, the difference is very huge. 15% difference is there. We can't accept it. Again, so that clearly represents a overfit model. So again, we have to decrease it and make the changes. Right. So what do we do? First, we start with using of this thing that is called models. With the models, we'll define over that I want to create a sequential model over here. Okay. Now, why are we creating a sequential model? See what exactly happened over here. We have how many words over here? We have 7 words, right? And 7 words, and there is one thing that we use as a padding. So it becomes 8, right? So first we have to define 8 neurons over here. Okay? 1, 2, 3, 4, 5, 6, 7, 8 neurons. Alright. Now when we define these 8 neurons, okay, thereafter after these 8 neurons, we have to decide what should be the end vector for each word. What should be the length of end vector? Okay. So here vector size for each word. Vector size for each word is what? Vector size for each word is 8. Okay. I want the vector size of each word should be 3. So I define 3 neurons over here. That is output neuron. Okay. Fine. And thereafter we can just connect it directly if we don't want to use hidden layer. Otherwise we can also use hidden layer if suppose here it is not required. But if I want to use hidden layer, I can use it. Right? Suppose here it's like just a minute. Here it is not that required because a very small size of data. But if I want, I can just add a hidden layer. So now when this process will go on, okay, what happened? Your vector, which is initially, this will be like this. Okay, this is how it will get connected. Okay, it will just connect like this. Right, let me just connect it for, then I will explain it. Okay, like this, and thereafter one more, some other color I'll use. What color? Blue. Okay. So now what exactly happened over here? When you feed the value, like suppose you feed the first word input. So first word input you are giving over here as 0, 1, 0, 0, 0, 0, 0, 0, right? So now this word will go. Okay, these weights will just defined. Okay, and based on the weights, these outputs will be calculated. Okay, the output of these things will be, it can be like say 0.15, 0.30, 0.75 kind of thing. So now your word will be represented by a vector like this. Okay, this will be the first word. Okay, then after second word will come, third word will come. So in this way, each word will be converted into a set of vector. All right, this is the first step. Okay, so let's see how it can be done. First, what we do, we'll define the sequential, and next we will just use over here model. We have defined that I want a sequential model, and in that model now I want to add the layers, right? So now this second thing will come into picture. First thing already did its job, defined a sequential model, and second will start adding the layer, right? So here when we do the layering, if I have to add the hidden layer, the function is dense. Okay, the function is dense, right? But we are not going to add the hidden layer over here. We are just adding over here embedding layer directly. Later on we can add hidden layer, but as of now I'm just trying to make this thing absolute simple. Now what we require, the first parameter that we required over here is what? Is input dimension. Okay, so input dimension is what? 8 unique, yeah, right. 8 unique words are there. Then I have to define output dimension. So this output dimension will depends upon the size of data. Okay. So suppose if you have very large data, then output dimension we keep large. Suppose I have suppose 1000 unique words are there. Right. So we keep the output dimension close to 10, 20. Right. But if we have lesser data, we can keep it small. Okay. Okay. Thereafter, we define our input length. Input length we define over the largest length. Okay. So here it is 4 because you know up to after 4 this also becomes 4, right? So that is what we define over input length. Okay. These things we define, and thereafter we just call over here model dot summary. Okay. So when I call model dot okay, output dimension is missing.
Sir, activation function.
No, activation function here it is not required. Just a minute, something what I'm missing here. It should layers. Oh, sorry, output dimension. It's output. It is not out. Oh, now what happened? Input dimension. I'm just sorry. Input length. It is input length, not input dimension. Input length. Fine. So it should give me the number of parameters. Why it is not generating the parameters over here? It should generate the parameters layers.embedding. It is just, is it library not working properly? Because it should generate. Let me just use over here tensor. It is working, but it is not giving me the number of trainable parameters. There must be some problem that is going on with this library. What it should return? Here it should return the number of trainable parameters. How many trainable parameters do we have over here? We have 8.
24 parameters.
Yeah, 24 is there, correct. We have 8 input neurons and 3 over here, so 8 into 3, it's 24, right? Okay, so it should show me 24, but
I think it should show.
Yeah, it should show. Here summary actually show, but
it should show 35.
Yeah, 24 plus 8 bias you are saying?
And 3 bias, 8 output layer.
24, yeah, at the output, okay, fine, yeah, right. It would be 3 bias, correct. 20, 20, 27 it should show. But
no. 8 input bias, 8 hidden layer bias, and 3 output layer bias. So 8, 3, 11 plus 24, 35.
No, here we are not using any hidden layer, right?
Okay. Yeah.
There is no hidden layer over here.
Sir, asking one question.
We have not added, just a minute, we have not added any hidden layer. So since it is not hidden layer, then 1, 2, 3, 4, 5, 6, 7, 8. Okay, then it is like this. So it will be connected over here only like this. So 8 will be 8 weights for this, 8 for this, 8 for this. Okay.
Yeah.
So now 1 you can add as a bias. So it will be 27.
Yeah.
So it should show 27, but no, like maybe library is going through some update or what, or it is saying what user warning argument is this, just remove it. So it is saying that I should not use input length. Then what I should use? Let me just remove it.
Sir, I really want to ask one question. Can we build a neural network without a hidden layer?
Yeah, see, logically, the definition says that without hidden layer, there is no neural network.
Because
Right.
single layer perceptron is also
Right. That is called perceptron. You said it right. That without hidden layer, there is, we can't call it a neural network. We call it a perceptron model. You said it like you are conceptually very correct. That means if you go in the theoretical definition, we don't call it. But yeah, as of now, just creating a basic one, right? Later on, I'll add hidden layer and all. I just want to create over here absolute basic. That's why I'm doing it like this.
Sir,
Mm-hmm.
sir, without activation function, how is it possible?
Yeah, we'll do. Don't worry. Activation function and everything I'll add, right? Don't worry about it. Okay. As of now, I'm just creating a basic one. All right. Okay. Just basic one. Without activation function is not mandatory thing. Okay. Why do we use activation function? What's the role of activation function? Can you tell me?
To classify.
Sir, to capture the non-linear parameter of data.
Correct. Activation function is used to break the linearity in your whole process. Okay. Because by default it will follow the linearity, right?
Yes,
So when we want to break the linearity, then we use activation function. So
Okay.
here it is here we are not applying any activation function and all, okay, because we are using what embedding function, right? And embedding function by default take care of everything. Okay, when we use layers.dense, okay, when suppose you are using layers.dense,
Okay.
then we apply activation function because dense will not do the other things, right? So don't worry, I'll explain, right? So here we are using embedding function, it will take care of everything, right? Yeah, please tell
Okay.
me.
So when you say that we need to break the linearity, okay. So what is the use of or how does it help to breaking the linearity?
I'll explain.
Okay, no problem.
I'm going to that part only, right?
Yeah.
So now what happened? This is done. Now this summary should respond with some of the parameter, but maybe some problem with some library, some changes may happen. No worry, I'll explore that documentation. As of now, this guy is embedding it, right? So for that embedded output, what we do, we'll just use over here model.compile. Okay. And while compilation, I will use over here Adam. Adam is your what? It is an error optimization process.
Optimizer.
It is an error optimizer, right? Correct. And then accuracy. Okay. This is like identifying the accuracy, and then we just use model dot predict. Now you may think like, why I'm using directly predict? Where is fit? Correct. So here actually we don't require any fit thing. I'll just a minute. It is padded sequence. Okay, fit will be required. I'll show you. Here we don't require fit because we are embedding. Okay, when do we use fit? We use fit when we build a model for prediction. Okay, here what are we doing? We are directly going for the embedding, right? So word vectors is equals to this one, right? So word vectors. Okay, so this is your word vector that is being created. Okay, now over here, if I will I want that some of the words should be common in both of them, right? So let me use something. I'm playing good, okay, and he is playing chess, right? I want one word to be common between them. Okay, he is playing chess. Okay, so now here there is something Okay, now this is what we have. This is a normal one-hot encoding. Right now, something will change. Input dimension will become 9, output dimension 3, and input length will become 5. Okay, so it's like if you say each word has to be converted it into a vector form. Okay, here the word which is common between both of them, like what is common? I am playing, right? I am playing and he is playing, right? So third word is common, right? So third word, is it getting the same vector? Okay, so it is getting the same vector, right? So now this did what? This just converted each word into a vector of our length, of our own choices. Okay, of our own choices, it just converted each word into a vector. Like I want I want a vector of size 3, so it has given a vector of size 3.
Okay.
Isn't it? That means now each word will be represented by a vector of word. Right. Now let me talk about the things that you are asking, like hidden layer, activation function, everything. Right. Now what to do?
Sir, in the result there are few negative. What is the significance of negative in this vector?
Negative significance, just a negative value, like if it is using a linearity is there, so in the linearity value can be negative, positive, it can be anything, right?
Okay.
Right.
So when you take the 3 vector, I have like one quick question. In the output, in the last layer, you take 3 numbers, right? How we decide those numbers? What was that?
Which number?
Like in the output layer,
This
the
one,
last
this one,
layer,
right?
you have So 3 circles were there, right? So
Yeah.
how you decide the number on those circles?
Okay, so there is no formula to decide that number. Okay, it just depends upon size of your data. Okay, see, if you have a very large scale data, like that means suppose your document size is having so many words, like you are working on a PDF having suppose
No.
10,000.
Not
Just
the
a minute.
number, not the dimension, not number 3. There are 3 circle in the end, for that. And those 3 circle has like, some number associated with these, each number. What was that number?
Where is 3 circle? Okay, the figure that we draw.
Yes. Figure.
Okay. It is the same thing. It is the same thing, right? This one. Okay, this one. Okay, that means if I have a word.
Yeah, 3
right?
circle. Mm-hmm.
Yeah. So if I have a word and I did what? This word is being represented like this. Okay, this is my first word. Okay, represented by a vector of how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9.
Yes.
All right. Right. Now, if suppose I have 1,000 words. Okay. So this process will give me a vector of size 1,000.
Mm-hmm.
Okay, that will be very big to train any model. Right. So using this process, what we do, we reduce the vector size to a smaller form.
Yes.
Okay. So it's like 1,000 can be reduced into a vector in which we can have only few, like 10 numbers.
Mm-hmm.
Okay, 16, 18, 15, like this, right? Or let's say 5. Okay, so there is a vector which was having in the actual form as 100 kind of thing, right? Which is representing a word. This vector is now reduced into a vector having just 5 numbers.
Yes.
Right? So for that we are using this neural network, right? This is just capturing your information and converting into a smaller dimension.
Yeah, but
Right.
it needs the target, right? What is the target value decided? Output value.
I'm telling.
Yeah.
See, this target value will later on affect, like suppose, see, now this value, that means this particular, the output dimension, whatever you're saying that I have an input size of 9 values and you have to reduce it to 3 values. Okay. Now, suppose I have these 2 texts and I want to build a model which can identify, like, okay, this is a text about cricket, this is a text about chess, okay, or this is a document about cricket. Okay, suppose I have a lot of sentences. Few sentences are about the cricket, few sentences are about the chess. Okay. Now I want a machine learning model which can easily identify that, okay, this is a text about cricket, this is a text about chess. All right. So for that, if I will use over here, okay, just a minute. See, I have 9, okay, that 9 I reduce to 3, okay. Now I will use these 3 features to train my model, okay. So if I use these 3 features to train my model, that means weights will be associated with these 3 features.
Yes.
Okay, that means if suppose using these 3 features, next I prepare one more neural network, and this neural network is working like this. Okay, like this.
No.
Hey, you'll get your answer. I got your point. Okay, let me get your answer, right? Okay, suppose this is the neural network, right? And based upon this, let's see.
Yes.
Let's suppose this one. Okay. Let's say over here, this will go to this point. Okay, this will go over here, and this will go over here. Then weights will optimize, and then output will get, right?
Yes.
Now the number of weights that will be generated over here, right, totally depends upon number of input features. Right? So suppose if you are working with a small scale data, right? So for a small scale data, a small number of weights will be enough. Okay? But suppose if you are working on a very large scale data, okay, so you require more number of weights for the training. Okay? So how can you increase the number of weights for the training? By increasing the number of input neurons.
Yes.
Okay. So how can we increase the input neurons? We can increase the input neurons by controlling this output dimension of the embedding layer. Okay. If during the embedding, after the embedding, I am giving over here output dimension 5. Suppose I give over here 5. Okay. So each word will be represented by a vector of 5 numbers.
So,
okay,
for neural network backpropagation to work, we have input and output layer should have some number. You put some number in those three circles, 0.15 or something. How we get this number initially? Because for backpropagation to work, we need something, right? We need to compare a target value, y minus y hat. So our y is like, these 3 circles. So when we put number first time in those circles, how we put it? I'm not talking about number of circles. Number can be like, we want, okay, whatever, suppose we want 3, 4, 5, that many circles are there. So we have said here, okay, we want 3 vector length. So we get 3 circle, but first time it has to go through, you see, y minus y hat. So y we need, right? First y. So
fine. Okay, so here there is no y. Okay. Here what is happening, okay, fine. So here, let me just tell you.
Let's do you can draw the 9 cross 6.
So here what you have, embedding functions you are using. Okay. So what embedding function actually did? It will take first your input neurons. Okay. So how many input neurons will be there? In this case, 9 will be there. 9. Okay. Now you have defined output neurons, right? Okay, and thereafter these input neurons will be connected to your output neurons like this.
Yes.
Okay. Now the responsibility of this particular process is to generate a vector of each word, and each word vector should be different from others. Okay. So here the weights will be, this library will define the weights over here in a way. The embedding function will define the weights in a way that if I have kind of 5 or 10 or 20 unique words, okay, so all words will get the different vector, right? But if I have the same word, like suppose playing, okay, so for the playing, let's say I am playing, the data is what? Let's say 001000. Okay, so when it went for the first time, the vector is generated. Okay, the vector is like 0.1, 0.3, 0.7. For example, it is generated, right? So when playing is going for the second time, this neural network weights should this should use the same output that is being generated earlier to fix the weights as it is. So that every time
as well.
Yeah, so that every time the same word should get the same vector.
Okay.
This neural network is not about training. This is about generating the output vector only.
Okay. And what if there is no two words? How it gonna know about that? If word, I am assuming that it passes it and it calculates with the random weight some values.
Correct.
That's good concept.
Correct. See, when I complete this thing now, you will understand everything, right?
Sure. Sure.
Okay. So see, suppose I have these two labels. Okay, like say I have these two sentences, right? I'm going. So I'll take 10-15 minutes more, right? Okay, because I just want to complete it. I just don't want to leave it, because if I leave it, it will again be difficult for you to understand tomorrow,
Sure.
right? So let's say I have these two texts, right? And using these two texts, okay, let's say, okay, suppose I want to build a system or build a predictive model which can predict or identify a text is about cricket or about chess. Okay, so how the process goes on? The first process is about this thing, like we just copy this thing, okay, and I'll just paste it as it is. So when you feed the data, this will do the embedding, okay, and after the embedding, we will do what? We will do the flattening, okay, model dot add. Okay, now the feed forward process, backward propagation, now you will implement everywhere. Okay, so model dot add layers dot flatten. Okay, now when we are doing this flattening, what will happen? When you do this flattening, this thing, that is the first text, okay, the first text, this whole thing will get flattened like this. Okay, it will just get flattened. Okay, that means this will go for this point, this will go for this point, this will go for this region, this will go for this region, this will go over here, this will go over here, this will go over here, kind of thing. All right. So just to make sure this whole thing will go into the input layer, so this is flattening. After the flattening that you asked me, like, is it possible neural network without hidden layer? Now here actually, that means this was done just to prepare the data. Okay, now here I can add the hidden layer. Model dot add layers dot what dense. Okay, now I can choose number of hidden layers. Let's say I want to use over here like number of hidden neurons. Let's say I want to use 4 hidden neurons. Okay, those who don't know about the neural network may get confused, but I tried my best to give you the high level understanding of neural network. Right. So input layer. First we just given the data which is getting the output vector of each word. These output vector are stored in the form matrix. Now this data I want to use for training. That means I want that model should identify in future any text is about cricket or chess. So this will be given a label 1, this is given a label 0. Right? Now this will be again given to a neural network by flattening. Flattening means will do what? Flattening will convert these things into a one-dimensional data. Right? I'll show you what flattening will do. Practically also I'll show you. Let's say I'll take this thing word vector, okay, and we'll use what? Dot flatter. Okay. So this converted everything into one-dimensional, but I don't want to convert everything into one-dimensional because this is the first thing, right? So what vector index 0 flatten, okay, and then what vector index 1 flatten, right? two sentences. This is representing your first sentence. This is representing your second sentence. Right? So now what happened? This will go to the input neuron first, and this will go to the input neuron second. Right? So if you are flattening this thing, suppose if you are flattening this thing, it will be a very huge data that will be there. Right? But if you are flattening this thing, here it is like comparatively lesser, and it will help you in learning the weights better. Right? Because here, how model can learn weights? Because most of them are zero, right? Isn't it? Most of them are zero. Say weights will be what? Anything multiplied by zero will become zero, right? So, in this case, only this guy will help in identifying the weights. Okay? But now model can learn more weights over here. Are you understanding why we required it? Right? Because if I use, like, you may be thinking, like, why are you doing this? We can create our neural network directly over here. Why are we converting this thing into a 3 vector and thereafter using it in the neural network? What's the reason? The reason is
reduce.
If I will directly use this thing into the neural network, the problem is we will not get the enough number of trained parameters because most of the values are zero. And what will be the trained parameters for these zero? Nothing, right? Because anything multiplied with zero will become zero, right? So there is no feed forward, no backward propagation. Okay, like if you create a neuron over here, right, and here is a hidden layer and there is output layer, and you say that, okay, I'll train it. Okay, fine, I'll train it, right? So you feed the value 0, 1, 0, 0, 0, right? And then you say that you have to get trained. You have to find out these weights value. What weight value it will find? Of some real numbers, right? And then we add over here neuron, that is hidden neurons and everything. Are you getting the relevance of everything now?
Yes.
Okay. So now exactly what happened. Each word is being converted to some numerical value. Now they will actually learn some weights. Okay. So that's why we are flattening it. Okay. So when we flatten it, so it will create how many neurons? 1, 2, 3, 4, 5. 5 into 4, 20. That means for each sentence, it will create 20 neurons, right? So these will create 20 input neurons, right? And then we can create number of hidden neurons, and those 20 neurons will be connected with next hidden layers having 4 hidden neurons. Now here you can add the activation function, but let it be. No need to add activation function right now because I want to explain you what activation function do, right? So I don't want to just add it for the sake of adding. So now I'll add over a last layer, which is your output layer. So output layer I will add only one neuron because my model needs to predict what? Either 1 or 0.
1 or 0.
Correct. My model needs to predict. Let me just define it over here. Import numpy as np. Okay, and thereafter we have 2 sentences. So for the first sentence, I will define the labels as np.array 1, 0. For the first sentence, the label is 1, okay, representing cricket based sentence. So for the second sentence, label is 0 for chess based sentence, right? So now what exactly?
If we have suppose tennis as well, then we will have 3 neuron, right? Like three different cricket, chess.
Yeah, tennis we can 3 neurons are there. You can. I'm just taking example of it as we have 2 categories, like sentiment analysis also. When we do, it's like 2 categories are there. Sentiment positive, sentiment negative, right?
Yes.
Okay, so it is like that only.
Yeah.
Okay, so the final my output should be what? Either 1 or 0. That's why this is my output defined. So that's why the output neuron I have defined 1. That means, first of all, the structure is like this. First of all, I have 9 input neurons. Okay, these 9 input neurons will create a vector of size 3 for each word. Okay, so now I have 4 words. So each or 5 words are there. How many? 1, 2, 3, 5 words are there. So these 5 words will have 3 vectors. Okay. Each word will have 3 vectors, right? Like this. Okay. Thereafter, what we do, we just convert this thing, we just flatten it. So we create an input neurons over here by flattening this thing, Now this is connected to hidden neurons, 4 hidden neurons. Okay, and then we are connecting it to output neuron. Right? Now this output neuron value can be 1 or 0. Okay, but the problem over here is what? This is having what? A linear nature. Because of linear nature, this guy can get a value from negative infinity to positive infinity, right? Okay, but I want a value to be 0 or 1. So here we have to break the linearity, and for breaking up the linearity, what we do? We use activation function, and activation function will be used over here like something which can generate the value in the range of 0 to 1. And to generate the value in the range of 0 to 1, 2 activation functions are used. One is called sigmoid, another is called
ReLU.
softmax. ReLU is 0 to infinite. Okay, so it is sigmoid, right? We are using what sigmoid does. Sigmoid will just give you the value in the range of 0 to 1. Why it will give you the value in the range of 0 to 1? Because the equation of sigmoid is this one, 1 upon 1 plus e to the power negative of this one. Now if you see, kind of, if you're not that good in mathematics, you may think, well, how it will give me 0 to 1. It will give you 0 to 1. I'll show you how. Let's say I'll write an equation over here. This is called linear equation, right? This linear equation will give you a value in the range of negative infinity to positive infinity, right? Now we just use exponential value so that it can give you the output in only 0 to infinite. Now it can't go negative. As it can't go negative, now we'll modify it and we'll write it over here like this, so that it can be, now it is, we know it will be positive, but I want it to be positive only up to 1. I don't want it to cross 1. Okay, so I will divide it by like this. Okay, because 5 upon 5 plus 1, it can't be more than 1, right? Isn't it? Now, if you will simplify it by dividing by the same value, you'll get this thing. Right? That means if you divide it by like this, okay, divide it by like this, okay, you'll get it. Right? So actually, you are using an equation. This equation will give you a value in the range of 0 to 1. Right? So during the process of backward propagation, the error optimizer will do what? Error optimizer will optimize these weights. Okay, what weight? These weights. It will optimize so that for those samples representing 1, weights can be tuned in a way that you will get 1. For those samples 0, weights will be tuned in a way that you can get 0. Alright, that is the purpose of activation function. Alright. Okay, so now we'll just use it over here, and thereafter we will do what? We can just compile, right? So model.compile. Okay, what I require? Optimizer, that is Adam. It will take care of all error optimization. Loss function for calculating the loss whenever it is binary
cross entropy.
We can use binary cross entropy, right? So it will just calculate the error with respect to your 1 or 0 and try to optimize that error. Metrics I want to monitor is, let's say, accuracy. During the course of training, I want to monitor accuracy. Okay, and then what we do, we can fit the data. So model is done. So I have to just fit the data. So where is data? Model.fit. Okay, where is data? The data is this one. We will just fit this. We'll just fit this padded sequence, right? This padded sequence will automatically be converted into what? This padded sequence will be first converted into your one-hot encoding. From one-hot encoding, it will be converted into word embedding, and from word embedding, it will go into the things, right? And this is your outcome. So features, and then we fit the labels over here. Okay, and then I have to define over here how many times of training I want to execute. Okay, so that is done through epochs. Let's say I want to train it for 10 times. So it will just run for 10 times, optimizing your error, right? So after some time it gets 100% accuracy. It's fine because we have just 2 samples. So it will not be a very good model, but yeah, just kind of a understanding like how training happens. So now once the model get trained, okay, let's say I have a sentence over here. Okay, so let's say I have a sentence, I am playing cricket. Now I want my model to identify this thing that it is 1 or 0. So what should I do? How my model can just identify it is 1 or 0? Yeah, tell me.
By capturing the semantic meaning.
Semantic meaning, like semantic meaning. Here we have not discussed the semantic meaning and all. Here we are just kind of discussing the word embedding only, semantic meaning.
Yeah, actually from the word embedding it will capture.
If you are using this term again, people will get confused like, okay, what is it? So semantic meaning we'll discuss later. See here, it's just a kind of a sentence. So first I have to make a prediction. So this sentence will be first converted into numeric form. Okay, and how it can be converted into numeric form?
Word embedding.
Text to sequence. Okay, this is how, right? So same, tokenizer is object which is converting into numeric form. So it's like we'll take it from here, tokenizer.text to sequence, we'll feed it over here. This guy will take care of this thing, right? Now, is it done? Shall I use it? No, I can't use it. Reason being, I have to use over here the same size of data which is used for training, right? So we had used in each sequence, we had 5 words. Okay, in each sequence we have 5 words, but here I have only 4 words. So before putting it into the model for the prediction, what we need? We need over here to pad it, right? So this is sentence to sequence done, and thereafter I have to do the padding. So how can we pad? For padding, the same object will pick from here. Okay, so it's a padding sequence, and this sentence sequence will feed it over here. Okay, post padding, because during training we use post padding, and then you have to define over the length. For defining the length, what is it? Let me use max len is equals to 5. Yeah, fine. So a 0 is added, right? So now my data is prepared for the prediction. So whatever the pre-processing that you did for the training, same pre-processing you have to do for the prediction. You take the text data, convert it into numerical form, and then you feed this data to this model. And rest of the job this model will do. This model will automatically embed it, flatten it, and then make the predictions. Now you don't have to do anything. So model dot predict. Okay. So in this thing, what you have to do? You have to just feed this particular data, right? So when you feed this data, this will be embedded and everything will be done. And we get a value over 0.49. So what is 0.49? We can just compare it if it is greater than 0.5 or not. It is not greater than 0.5, we're getting false. So we can convert this thing into integer and we get a value over here as 0. Is it a correct prediction?
Yes.
Okay, because 0 we had given for, I guess for the, no, it is not a correct prediction. 0 we had given for chess, right? Cricket we had given 1. So it is not a, obviously we can't accept with 2 sample, how can we accept a correct prediction? Okay, but yeah, this is a process that you need to know. Let's say if I'll use over here only playing cricket. Let me try with only playing cricket. See, it is not giving, it's playing cricket. Okay, let's say obviously it will not be a very good model. I am playing, I will use the same text, right? Playing good cricket, right? That is one. right? So which word, if I am removing the, suppose I am going to click it, right? Then what it is going to do? That is so if anything I am removing, it is not working with that particular efficiency. But yeah, this is a process that we can follow on the very large scale data. Tomorrow, what we do, we will use this process to build a model for sentiment analysis on a large scale data. I'll just take a data, some movie reviews kind of a data, and there we use a similar kind of process and we'll see how is it working. All right. Okay. So I hope the kind of so many doubts that you were having, like related to activation, related to dense layer or hidden layer, like how a neural network can be without a hidden layer and all, right? So I hope those things must get cleared by the end, right?
And is this called Keras embedding or general embedding? Like, is it like PyTorch has different embedding? Is it like this, or it's a general embedding?
It is because we are using Keras library for the embedding, so we call it a Keras embedding. That's it, right?
And I have one kind of query or question. You can say that for the questions, sometimes it takes a long time. Is it? Do you have anyone like you or anyone available on maybe daytime or some time to discuss if someone has doubt or something?
Yeah, you can. We can reach out to me anytime. Like whenever you want to reach out, you can reach out to me. It's fine. And like suppose sometimes maybe I'll not be available immediately, but I'll definitely respond. Okay, you can just text me as well, right?